मान्छे हो पागल
फजूल थोड़ी डाउट वाला ही करना है अभी।
A very good morning to all of you. I, Dr. Pranshuman Parashar, co-coordinator of First 17 Days The Pressure Course 2022, welcomes you in today's session. For today's session, our eminent resource person is Professor C.P. Gupta, sir. So before starting our session, let me introduce our resource person. Dr. C.P. Gupta is presently professor in the Department of Management, Department of Financial Studies, South Campus, University of Delhi. He is M.Com, M.Phil in Finance, PhD in Finance from Department of Commerce, Delhi, School of Economics, University of Delhi. He has teaching and research experience of more than 30 years. He has contributed a number of research articles in various Indian and international journals, and he has few research-based books to his credit. He is involved actively in the training programs of NTPC, ONGC, ABB, Sapient, EXL, IBM Daksh, and others. He was a member of the expert group appointed by Government of India to review cost accounting record rules and existing cost audit report rules. He is area editor of Journal of Indian Business. Without any much further delay, I would like to hand over the session to our eminent resource person, Professor C.P. Gupta. Sir, please. Sir, am I audible to you?
You have to, yes, sir. You have to allow me to share the screen.
Okay, sir. You are from some other device also. All right. 1 minute. Sir, now you can share.
Okay. Pranshuman, should we start?
Yes, sir, please.
A couple of things I would like to know. If a participant want to talk to me, is the participant allowed?
Sir, your voice is a little bit uh, slow. slow.
कर रही है क्या आवाज ब्रेक कर रही है आवाज ब्रेक कर रही है क्या
No, no, voice is not breaking. अब थोड़ा सा clear आई थी sir. But earlier it was a low voice.
okay so now it's okay.
Now it's okay, sir. Yes.
So what I'm asking is that if a participant want to talk to me, is the participant allowed?
Yes, sir, it is allowed. He has enabled the unmuting facility for all of us.
Okay, so they can unmute themselves and then they can put their query to me if they wish, right?
Yes, sir. Yes, sir.
Yes, sir.
Great. How many total participants are there? Because we have around 45 plus participants so far.
Sir, some of them are joining, and there are around 120 participants. So I'm just sending a message that everyone should know.
What is by and large their background? They are from all background or they are from a particular background? Are they from diverse background or are they from similar background?
Yes, sir. Some of them are from all like commerce and management, and then also from IT field also.
Okay,
So they are from the diverse backgrounds.
okay.
From engineering also, sir.
Hello?
From engineering side, I'm from engineering side.
Engineering field also.
Okay, great.
So all are not from finance, sir. So you can consider the finance for non-finance kind of thing you can integrate into your delivery.
I'm not going to talk about finance, but I just want to know what kind of background they have. Anyway, so friends, good morning to all of you, and let's start our session on regression. I will be there with you throughout the day. And let's start with some good thoughts. And let's start with great positive energy, which you require throughout the day. Friends, it's your day and you have to make it a fruitful day for yourself. So time to learn, and it says have patience, and it says it teaches us art of patience. It's an art of waiting without tiring of waiting. And when I say you have to have the patience, that means in the research and in your learning journey, many times you will find the results don't come immediately. You have to wait for them. And therefore, you have to have patience. And when you are having patience, right, you should not feel tired of waiting. And that's a very important lesson for all of us. Wait, but wait without tiring. That's what patience means. So please understand that every session has a motive behind. So this session is also having a motive, and the motive is twofold. To make you comfortable with regression. So we'll be devoting a lot of time in understanding the regression and its different dimensions and variations, and we will also learn to implement regression. And that's the agenda which is given to me, okay, for this particular sessions or regression. And it's a session where everyone is under learning mode and learning with proper understanding. So the motivation of the session is we have to understand our research problem and to answer that research problem, we have certain research questions which we would like to answer by using certain tools, and the tool which we are going to discuss is regression. So first we have to be clear what kind of research and research issues requires use of regression. And once you feel that, yes, you have a motivation for using regression, then you can appreciate the whole sessions which we are having today. So friend, let's start our session with the thought. This thought is very dear to me. It says, if you cannot explain it simply, you don't understand it well enough. That means what? Something which you understand, something with which you are comfortable, confident. You can explain it simply to anybody. If you don't understand, then you will start making things complex and you may not be able to explain to the audience in a simple way. Understanding of the things are very, very important. And I believe many of you are teachers and they must have experienced the topic which they understand, the topic about which they're confident, the kind of the delivery they do in the class is unimaginable. You must be feeling highly satisfied when you deliver something which you understand. And if you don't understand and forced to deliver, you will be having irritation, or maybe you're not that much satisfied as you should be. So friends, we have to learn with understanding. And for understanding whatever queries, whatever questions, whatever doubts you have, please don't hesitate. You can unmute yourself, talk to me directly, or you can put your query in the chat box. I'm continuously looking at them and try my best to answer those queries. But make sure that you understand. I'm emphasizing and repeating. You have to understand that one of the greatest motivation for me behind this particular sessions. So with this backdrop, let's move ahead and let's come to our agenda. But first, what causes impulse buying by customers? What are the factors impacting motivation level of workers in the organization? Why companies go for leverage? Debt. Do we really find in real life negative relation between price and demand? How to answer these questions? If you wish, you can share with me your research topics. And then I will show you whether you can use regression in that case or not. So for example, you want to find out what determines work-life balance in the life of the workers or executives in a particular industry or organization. When I say what determines, you know what I'm trying to find out? Anybody? The moment you say determines, what does it mean? There are certain causes, certain factors which are impacting your work-life balance. These are my causes and these are my output or the resultant or the effect. That means I'm trying to study causal relation between the variables. Do you think that demand is a function of price? Simple example. So what I'm assuming, price is my cause and demand is my effect. And I'm trying to establish a relationship between them. If I do this, then I must make use of regression analysis. Price is the causal factor and Satbir measured in some way, okay? So Satbir ji, if you are trying to do some research, which is causal research, then you may use regression analysis in that case. That's the point which I'm trying to explain to you. Impulse buying, my effect and the factors which are determining it are the causes. Factors impacting motivation level, these are the causes, and the motivation level is the effect, like this. So whenever you have this kind of situations, this kind of research issues before you, you can think of using regression analysis. And the research design is what is called the causal research design. And one of the statistical tools for analyzing data under causal research is regression. And that's what we are going to talk about. I'm sure many of you are not hearing regression for the first time. When somebody say regression, what is the picture comes to your mind? If somebody says regression to you, what does it mean to you? What kind of reflections you start getting in your mind?
You can say relationship between variables.
Relationship between variables. Then
One variable is changing with respect to other variables. So we can
also gives you the relation between the variables. But there is a basic difference between the regression and correlation. Relationship, impact of one variable on the other. Yes, Dr. Prashant is saying that means we are saying that the y which we have is a function of a number of variables, x1, x2, and so on. This is my dependent variable, and these are called my independent variable. And we are trying to study how independent variables are impacting my dependent variable. Yes.
Good morning, sir. Sir, I have a question. Suppose I would like to find out the relationship between the COVID and the impact on Ayurvedic medicines. Right, sir? So it is a correlation or a regression? Because sometimes I am confused. So what I have to be used, correlation or regression?
Smriti, what you are trying to see, the medicine, impact of the medicine on COVID, right?
Yeah. Ayurvedic medicine, impact of Ayurvedic medicine.
Yes. So these are my causes. These are my effect. You can make use of regression.
It doesn't, sir, what is correlation then?
Correlation gives you association. It doesn't tell you what is cause, what is effect.
Okay. Impact can be decided on the basis of regression.
Can we?
Sir,
Smriti?
if we want to find out the impact, then we have to use the regression.
Right. Impact, dominance. Okay. Cause and effect relationship. There you have to use regression.
Okay, sir. Thank you, sir.
Relationship of two variables in which independent variable is contributing in terms performance of dependent variable. Yes, right, you are right. So we see the relation between the dependent variable and independent variable when we do regression analysis. So we have one dependent variable and a number of explanatory variables. Dependent variable will be one, that's what we are assuming, y is one, but your x's can be many. The independent variables can be many. This is explained, and these are the variables which are explanatory variables. So they explain what is happening in Y. Okay. Another thing is these are determined outside the model. They are called exogenous. And these Y determined within the model, it's called endogenous variable. So different names you will find people are using for Y and X, and you have to understand it. So first, let's start with a simple regression model where we have one dependent and one independent variable, and that's normally called the classical linear regression model. So yi is equal to alpha plus beta xi plus error term. That's your intercept. This is slope parameter. This is your error term. And error term behaves randomly. Behaves in a probabilistic manner. And you can say it behaves in a stochastic manner. So if error term is behaving stochastic in a stochastic manner, then y, which is the function of your right-hand side, then it will also behave stochastically or probabilistically. And therefore, yi also becomes stochastic. Which means the whole model which we have, the model which we have, y is equal to alpha plus beta x plus error term. I'm dropping the subscript I because I represents each observation. For simplicity's sake, I'm dropping that subscript. This model is called stochastic model. And it is called a stochastic model because of the random behavior of the error term. So when error term behaves randomly, y becomes random and the model becomes a random model. So every classical linear regression model is stochastic in nature due to the error term, as the behavior of the error term is random. Error term takes care of other things being constant. Ceteris paribus. You have y is equal to, okay. I think demand. We know demand is a function of price. Do you think that demand also impacted by factors other than price? Any other factor which you think impacting demand,
Yes,
which
sir.
is not in my model?
Income of the customers, economy level.
Income. So I'm not taking income into my model, but income does impact, and therefore the effect of the income will be sitting in the error term. Prices of the substitutes, not in the model, it will sit into my error term. They do impact, but we have not taken them in our model. So they will sit inside the error term. And that's the reason we are saying that it takes care of other things being constant or ceteris paribus. Yes, Prashant, the taste and preferences is also one of the factor. Now let's look at the assumptions which we make for our model. Model is a model, it's not a reality. And that model is based on the set of assumptions. So let's try to understand the assumptions. Any one of you can recall the assumptions of the regression? Yes, Satbirji. Rohit, Dr. Prashant. Any assumption that comes to your mind?
Sir, in the cases of expensive good, the demand, this equation will be violated because as the price increases, demand will not be increasing.
Okay. So the relationship may not exist for the
Expensive good.
luxury good. That's what you're trying to say?
Yes, sir.
Okay. That data will tell me what kind of relationship exists. That's a different question. Data of independent variable is normally distributed. That what Satvir is saying. Satvir is saying. No, Satvir, that's not the assumption. We don't make any distribution assumption about independent variable. Never.
Okay, sir. Thank you.
Okay. So let me, you will find all the assumptions are primarily with error term because error term behaves randomly and there's a need to discipline the behavior of the error term. And therefore, we put a lot of structure on the error term. Mean of the error term is 0. So in some cases, it will be positive, some cases it will be negative, but overall, we are assuming the impact of the error term should be 0. We are assuming the variance of the error term is constant, and that property is called homoscedastic. We are assuming that error terms are not correlated with each other, no autocorrelation. We are assuming the covariance between x and the error term is 0. So independent variables and error term, they are independent of each other. That's what we are assuming. We are assuming that error term follows normal probability distribution. And finally, we assume that x's are given to us. We know them, they're constant. They don't follow any kind of probability distribution. And when error term follows normal distribution, my y also follows normal distribution. But we have no assumption about x. We don't care whether x are normally distributed or they are not normally distributed. Our assumption is about error term. Okay. So now the challenge is you have a equation y is equal to alpha plus beta x plus error term. Okay, we know x, we know y and x, but we do not know alpha and beta. So the challenge before me is how to get an estimate for alpha and beta. Okay, so Babita is asking homoscedastic. Homo means constant, scedastic means variance. So we are assuming that the variance of the error term will be constant. Say if you have 100 observations, right? So I take 50 observations, calculate variance. Another 50, calculate variance. That will be same. It will not be different. Whatever set of data you take, the error term variance. Okay, Babita.
Yes, sir.
Puram, what assumption you think I should explain to you? Puram Sharma. What assumption? Which assumption is not clear to you? Puram, tell me the assumption. I will explain. Third number. Okay. Third number is no autocorrelation. That means no correlation between error terms. That means all error terms are independent. That's what we are observing. Okay. So if you take errors and then calculate the correlation between the errors with the lag, there will be no correlation among them. All are independent of each other. That's what we are observing. And how do we get the estimate of alpha and beta? That's the challenge which we have for our model. And to estimate the value of alpha and beta, we have two methods, ordinary least square method or called OLS and MLE. We will be talking about OLS, simple, easy, convenient, and gives you the best result. For a classical regression model, both OLS and MLE estimate give you the same results, but intuitively, OLS makes more sense. And therefore, we go for it. And what OLS does, we have value of the Y, we have the value of the estimated Y, which is your error term, square of the error term. So minimize this with respect to alpha and beta. Simple calculus problem. Prashant, beta is not equal to y upon x, please. We have to estimate them into our model. And we have to estimate it from the data. Once you get estimation of them, then you can say beta is equal to y upon x.
Okay, sir. Sorry, sir.
But Prashant, where is your alpha gone? Alpha भी तो रहेगा आपकी equation में.
Yes, sir.
So this is not correct. Beta is equal to y upon x. It's not correct. What you can say that beta is equal to change in y with respect to change in x. That you can say. But beta is not y upon x. Yes, sir. The calculations are required to get the results. And in this case, we get beta that's equal to covariance between X and Y divided by variance of X. Once you know the beta, then I can get alpha that's equal to Y mean minus beta X. And we get estimate. So to show estimate, we put a at sign on it. So the difference between alpha and alpha hat is the parameter and alpha hat is the estimated value of that particular parameter. Similarly, you find the difference between beta and beta hat. Beta is a parameter and beta hat is the estimated value of that particular parameter. The OLS estimate which we get, they are blue estimates, best, linear, unbiased estimators. And therefore, given a choice, we always prefer OLS. And OLS are best because they are linear, unbiased, efficient, consistent, and sufficient.
Sir, can you please explain the Markov theorem, sir, once again?
Explain what?
Markov theorem in the previous slide, sir.
Okay. Markov theorem says that the estimates of the OLS which we get, they will be blue estimates. They will be best because they have the minimum variance, linear functions, unbiased estimators. That's what it says.
Thank you, sir.
They're the best estimators. They also satisfy certain other conditions like linear, unbiased, efficient. They are also consistent and they are also sufficient.
Sir, we are talking about estimates or estimators?
सतवीर जी क्या फर्क लगता है आपको दोनों में?
Estimators are basically independent variables, you mean to say, sir?
Estimator is method which we use.
Okay.
So OLS is my estimator.
Okay,
Maximum likelihood is my estimator.
okay, sir.
Okay, I ask you a question. You have a population, right?
Sir.
And you got a sample. And you want to determine a best measure of central of tendency
For the population.
for the population. What should I take? Should I take mean? Should I take median? Should I take mode? Should I take quartiles? What should I take?
Okay. So there are various options available.
Right. So which one I should take to get the best?
I'll take sample and determine its mean as a
Sample mean.
sample mean.
Sample mean is considered to be the best estimator of population.
Yes, sir.
It's unbiased, it's efficient, it's consistent, sufficient, and therefore mean will be my estimator.
Okay, sir. Understood.
The actual value which we get from the sample, that will be my estimate of the mean. That may be say 9.54. That's my estimate.
So sample will give estimate mean.
Yes, because that's a formula I'm using to estimate population.
Okay, okay, sir.
That's my estimator.
Okay.
The actual value of the estimator which we get, that is the estimate.
Okay. But sir, you mentioned OLS estimators because OLS is one single method, no sir. So OLS we can OLS estimator we should speak or OLS estimators.
OLS estimator.
Okay. I was
Because
confused with the OLS estimators.
OLS is a procedure.
Okay, sir. Understood.
And since alpha, beta are the estimates calculated from sample data, they also have some statistical properties. So what's their distribution? What's their mean? What's their variance? Babita, why do we need all this information about our estimates? Why should I bother? क्या distribution है उनका? Why should I bother about it? होगा distribution होगा, हमें क्या लेना देना? जनक, शालिनी, प्रतीक, भारती, Rachna, so many people are there. Can you imagine why should I study statistical properties of my estimators?
Sir, to rule out the assumptions, first of all, we have to find out these statistical measures and then we will go for regression.
So we have to find out the statistical measures. We got the values of alpha hat and beta hat. Suppose alpha hat is equal to 10.5, beta is equal to 2.65. We got the values. So what? रचना जी क्या करें इसके बाद? हो गया हो गया. Why should I know their distributional properties?
Sir, because in regression, sir, when we do the regression, we have to plot a graph. So we have to find out first alpha and beta values, statistical
वो तो
measures.
आ गई ना, अल्फा बीटा की तो वैल्यू आ गई. अब ये कौन सा डिस्ट्रीब्यूशन फॉलो करते हैं? टी फॉलो करते हैं, जेड फॉलो करते हैं, क्या करते हैं? हमें क्या लेना देना उससे?
बिकॉज सर उसमें है कि जो डिस्ट्रीब्यूशन है सर नॉर्मल assumptions जो है नॉर्मल होना चाहिए.
क्या नॉर्मल होना चाहिए? नॉर्मल तो एरर टर्म होनी चाहिए. नॉर्मल तो एरर टर्म के बारे में assumption है ना हमारी. हमारी जो assumption है
जी सर,
वो तो एरर टर्म के साथ है. That error term should follow normal distribution with zero mean with constant variance.
sir, but before we apply the regression, we have to find out.
इस assumption का consequence क्या है? Y also follows normal distribution.
सर बिकॉज फाइंड आउट करेंगे, अगर नहीं होगा तो फिर कोई उसमें सर और जो टेस्ट है वो लगा के देखेंगे फिर उसकी
नॉर्मल की जरूरत क्यों है हमें? अगर नहीं है नॉर्मल तो क्या हुआ? क्या प्रॉब्लम? कोई प्रॉब्लम थोड़ी है.
सर फिर होमोसिडेस्टिसिटी की बजाय हेटेरोसिडेस्टिसिटी आ जाएगी.
Diversity is the difference. That is find out how much the variable are highly correlated. That is find out by homocytosis.
Homocidesticity
अगर
should be
वो
maintained, ना सर.
assumption violate हो रही है, होने तो हमें क्या लेना देना उससे? हमारा तो रिजल्ट आ गया ना उससे. Okay, suppose I take y is equal to alpha plus beta x plus error term, and my estimated model is y hat is equal to 0.95 plus 2x. Error term is 0 when you estimate it, so we don't write this. Suppose I want to check a hypothesis. My beta is equal to 0. Alternatively, my beta is not equal to 0. How to test? How to test? how to test. अरे hypothesis testing कैसे होगी?
टेस्ट करें सर,
हैं?
ये टेस्टिंग करके सर.
Sorry, can you repeat?
Shall we use t-test?
T-test के लिए क्या assumption है? टी का डिस्ट्रीब्यूशन तो पता होना चाहिए ना हमें टी का. अगर आपको टी का डिस्ट्रीब्यूशन ही नहीं मालूम तो आप टी कैसे लगाओगे?
टी टेस्ट के लिए नॉर्मली डिस्ट्रीब्यूटेड होना चाहिए. इट इज ए पैरामीट्रिक टेस्ट.
मुझे इन पैरामीटर का डिस्ट्रीब्यूशन मालूम होना चाहिए ना, तभी तो मैं अप्लाई कर सकता हूँ.
जी सर.
इनका मीन क्या है, इनकी स्टैंडर्ड एरर क्या है, कौन सा डिस्ट्रीब्यूशन फॉलो करते हैं. अगर आप ये सब नहीं जानेंगे तो आपकी जो हाइपोथेसिस टेस्टिंग है वो नहीं हो पाएगी. Organizers, is there anyone who doesn't understand Hindi? कोई है पार्टिसिपेंट ऐसा जो हिंदी नहीं जानता हो?
So I am also.
Sarika, international participants are there. Okay. Okay, so I will try to stick to English. I won't be speaking Hindi. Okay. So we have to understand the underlying distribution of alpha head and the beta head. And since my error term follows normal probability distribution, we can show they also follow normal probability distribution. That's the mean, the alpha, because it's unbiased estimator, that the variance of the alpha head. So both follows normal probability distribution with mean and variance, which are calculated like this. And Y also follows normal probability distribution, and its mean is alpha head, beta head, mean of the X, and that's how we get the variance of Y. It also follows normal probability distribution. Error term follows normal probability distribution with mean 0, variance constant, and that's how we get the variance of the error term. Friends, we need not to understand and remember these formulas, but we have to keep in mind that they are the variables which are following a normal probability distribution. They have their own mean and they have their own standard error. And most of the software will give you their standard errors and their mean when they give the results. So we have a regression model. Just a minute. We estimate using OLS. And we know the properties of estimators. OLS estimators. They are blue. Best linear unbiased estimator, and the alpha head, beta head, Y error term all follows normal probability distribution. Yes.
So what is unexplained variance?
What is?
Unexplained variance.
Unexplained variance.
Yes, sir.
Rachna, can you imagine what is it? Variance which is not explained?
Sir?
Variance which is not explained by the model?
Yes, sir, that I know. But in the sir, in equations, sir, sometimes it is confusing when I am writing the paper. So how can I interpret it? That is the problem. So
if there is a variation in Y,
yes,
variation of alpha, which is the constant, is 0,
yes.
right? So you have variation in Px plus variation in the error term, isn't it?
Right. That's it.
Can you explain this, why this is happening? Can you explain why error term is there? Rachna, tell
Error
me,
term is not explained in the
can you explain why variation in the error term? This is unexplained.
notice.
And this can be explained by X.
Yes, sir.
This is explained.
Right.
Okay. So if I divide both the sides by variance of Y, what I get? What I get? 1 is equal to, this is your percent explained plus percent variation, which is unexplained. Any one of you, what that number which tells me how much percentage of the variation is explained by my model? Anyone?
Sir, no. So the best is more
R square.
than 70%.
R square.
R
1 minus R square is unexplained. So R square represents the percentage of the total variation explained by the model. Any question, friends, before we go ahead? Any doubt, any query?
No, sir.
So let's take an example, and first I will do in Excel because Excel is available for all of you. And just take a simple problem, and once we did with Excel, then we will practice with R. So we have there is a file XY data. And you can, simple problems of regression, you can do very comfortably with regression. So we have data X and Y. So to perform regression on it, you go to data. In that you will see the option data analysis. And when you click on data analysis, you will get the option of regression. Select that. It's asking for Y input. This is my Y. Asking for X. This is my X. Both are having labels. That's the result which we get. Go to data analysis, regression, give the necessary input, you get the result. So let's read the result now. Y is equal to, this is the intercept, 39.348 plus, this is beta, this is alpha, this is beta, 2.828x. This is my estimated model. Then these are the estimates from the sample. So they are the corresponding standard error. This is the standard error. And we get the T statistics. Null hypothesis for T statistics is alpha is equal to 0. Alternatively, alpha is not equal to 0. Similarly, beta. Beta is equal to 0. Alternatively, beta is not equal to 0. So how do we get the value of T for this? T will be 0 minus alpha estimate divided by standard error of alpha. I show you how do we get this. This minus 0 divided by standard error, and that's the value of the T. Similarly, you can get for the B. And their associated probability values are this. That means they are significantly different from 0. These are the confidence intervals for alpha, beta. Normally, we don't need that, so I'm just ignoring it. Any question about this part of the table? Any question?
Sir, what does the coefficient represent?
Coefficient represent first represent your intercept. Second, represent coefficient of x. Coefficient of x is nothing but your beta.
Okay.
So this is your alpha, and this is your beta. Okay.
Yes, sir.
This is my y. What is it? Multiple r. It's a correlation between y and predicted y. It's a correlation between y and the predicted value of y. And if you take the square of it, you get the r square. if I take the square of this number, I get the value of the R square. What is adjusted R square? That we will take later on, not now. This is the standard deviation of error term, 4.170. And total number of observations are 24. Okay, so any question from here? Then let's, yes, Rachna.
What is the difference between R square and adjusted R square?
I told that adjusted R square we will discuss later. Just give me time. Okay. What is this total? And what is this number? And what is this number? This is very important for us and we have to understand them. This is total sum of squares of y. That means this number represents total variation in y. Out of it, regression is explaining this much. So this is my explain. This is my total. If I take a ratio of this, can you imagine what you will get? If I take a ratio of these two numbers, this divided by total,
I think we'll get 4.17, sir.
what will we get?
Around 4 something.
Yeah, but what is that? Rachana, tell me, I told you earlier also, what is it?
Which one?
The regression variation divided by total variation. What is it? This
Sir, it is coming
plain
0.445.
variation.
R square, it is coming equal to R square, 0.445.
Yes, this is explained variation. It is equal to R square. So what does it mean? It means the following. We have a total variation of 9.260. Out of it, regression is explaining 306.732 and unexplained is error term, unexplained, that's 382.528. So explained by total will give you explained by total will give you R square. And that's what we get here. And when we divide them by degrees of freedom, we get their variances. Ref is nothing but the ratio of two variances. So,
Sir, in this case, can we say that X is explaining 0.445, that is 44.5%, and error terms explaining rest?
yes.
But sir, total, it should represent 100%, no, sir? So in this case, we will say that that means 54.5% will be explained by error terms, right, sir?
No. Regression, explain. It is the explain part. It is the explain part.
Sir, in this case, 44.5% is explained by regression. That means X, sir, right, sir?
Yes, explained by X.
And the rest of the explanation of errors is due to error terms, right, sir? And total will be 100%, right, sir?
So F is nothing but your 306.732. Sorry. 306.732 divided by 17.388, which is coming to be 17.6. And F is telling me whether the variation due to regression or unexplained, whether they are significantly different from each other. And it says F test says the variation explained is much more than unexplained. Therefore, my model is having significant explanatory power. That's how we got it.
Can you please come again, sir? On F value type.
F test is a test which tells me how much, whether the variation explained is significantly different from variation which is unexplained. Higher F, it means more explanation as compared to unexplained. And F is to be coming to be significant. That means the model which we use is a significant model. Has explanatory power, can explain my Y given X. Any question about this output? Because I'm not going to repeat this output again. And whether you use R or use any software, you will get the same output. Of course, the format might be different.
Sir, how can F value remain same for regression as well as for residual, sir?
It means
it is by default coming in the formula, sir?
They means what? These two values.
Yes, sir.
Second value I have calculated.
No, you have calculated, but for regression, SS divided by MS. Right, sir? So for residual, it is coming okay, 17.641.
Yes, this. This is equal to T12. That's what we get. Second value I've calculated myself just to show.
Okay, sir.
Software doesn't give you that. Friends, make sure that you understood each and every part of the output. If something is not clear to you, please let me know. Because In our further discussion, I will presume that you know all of them. No query, no question. That means you have understood the whole output of regression. And when we report our results and when we work with the regression, two important issues we have to remember. Number one, how to report the result of the regression output which you get in your research article. Should you take the whole table and paste in your research article? You copy the whole data and copy from here and paste in your research article. Should we do that? Answer is no. We should
I
not.
think only intercepted X portion we can.
So what information we should reflect in our research article, that's something we have to understand. So we should first explain our underlying theory. Then what is your testable model? Our testable model is y is equal to alpha plus beta x plus error term, sample size, and estimated equation. Say in our example, it was 39.348 plus this is my estimated equation. Then we should also mention the standard error before the intercepts. Sorry. So we have to mention, just a minute. The standard error below the parameters which you have estimated. Then give the R square of the regression. That's it. If you give this these pieces of information, then you are giving them all relevant information. And the reader can generate whatever information he wants to generate. No need to give it to the person. Okay, so that's how you can report. Another important thing which you have to know is how do we know whether our model which you have fitted is a good model or a bad model? How do we know that? What measures I should look at in order to know that this is my best model? So for that, we have to look at the following numbers: R square, higher R square, better is model. The standard error of regression, lower it is, better it is. And this is nothing but variance or standard deviation of error term. Lower it is, better it is. F value should come significant in your ANOVA table and significance of the coefficients of the variables which you are using in your equation. If these conditions are satisfied, then you can say your model is a good model. Okay? Before we go further, let's do a simple exercise in R. So first I have to activate R. Sorry. So the way we will be proceeding is reading the data, making graph to get a feel of the data, and then running our model. So first, let me read a CSV file. Okay, history. So let me read a file with the name of debt, debt equity ratio and beta. So I'm just reading CSV file, and header is true. That means header is having a variable's name. So let me check. Let me start my R studio, and then we will work on it. So first we will read the data, we'll make a graph, run the regression model, and come out with the result. Just a minute. I have to put it in the general framework. Yes, right. So first, let me read the file, which is a CSV file. So I go to my file. Sorry. And if you want to see the structure of it, you can write the command str debt equity ratio. That will tell you the structure. The variable which we have DE underscore ratio is a data frame, and it has three variables: the name of the company and debt equity ratio and beta. These are the three variables which we have. Name we don't need, so we have to work with debt equity ratio and beta for the variables. Then if you see what is in the data, you can see the tail of the data. These are the last 6 companies in my data. These are the top 6 companies in my data. And to use this file again and again, I'm attaching it. Then I can make a scatter plot simply. That is scatter plot. And if you want some options in it, you can options in it. That's the type of your scatter plot. And if you want color, say green, you can write green color. So that this is a scatter plot between debt equity ratio and beta. Then to run the regression, we have a very simple command. Please understand. To run the regression, we have a very simple command, LM. LM stands for linear model. So first we write dependent variable, followed by tilde sign and independent variable. That is syntax for running regression. And if I just run it, you can see the result. This is the intercept, this is the coefficient. So my estimated model is that beta is equal to debt equity ratio is equal to minus 0.072 plus 0.855 beta. That's my estimated equation. If you want details about the output, you can have those details. For that, you have to write summary result. So you have the estimates, you have the standard error, you have the t-value, and beta is coming to be significant. While intercept is not coming to be significant. And R square is 19.04. So this model is explaining 19% variation in debt equity ratio caused by beta. If you want to fit the line, then and want to make a graph of it, you have to use the command line and the result. That's the fitted line of the model which we have. If you want red color, you can write color is equal to let me open up another file. Just cancel it. Let me take some more file. Friend, just give me a minute. I'm opening up a file. Anyway, I think let me take another example. So I go to File, Import Excel file. So first I will make a scatter plot, simple plot, and then I will use the LM function to get the regression result and see the results. So let me take File, Import from Excel. Then browse. My file is sorry. I take that XY data. I simply name it as X underscore Y. So I have imported the file, and the name of the file is X underscore Y. So plot X underscore Y. So that's the plot which we get X and Y. If you see the structure of the structure of the data is X underscore Y. That's my structure of the data. So I can plot $y as a dependent variable and X underscore Y. That's my scatter plot. If you want solid circles, E19 color dark red. That's what you get. Then say X, Y result is equal to LM X underscore Y dollar Y tilde sign, then we have X underscore Y run it. Then X, Y result that the intercept which we get. And if you want summary of the results, write XY underscore RES That's the summary which we can do. So you can easily do in Excel in R by using these commands. Okay. So friend, this is the beginning. If you still have a question, any doubt, let me know. So let's have a break. And after the break, we will come back.
Yes.
What should be that?
Sir,
Yes.
sir, kindly share the commands, please, so we can try ourselves also.
Okay. I share the commands with you. Should I put in the chat box?
Yes, sir.
I put it in the chat box. Okay.
Thank you, sir.
So,
Okay, so
tell me what time we should be back.
okay, sir. So participants, we will be meeting again and after 15 minutes for the second session today. So please remain here, and we will start our second session from 12:55. Thank you.
Thank you, sir.
Okay. Just a minute.
Not
So again, I welcome all of you in the second session.
So should we start? Shuman. Hello. Ashman, are
Yes,
you
sir.
able to hear me? Should we
Yes, sir.
start? Okay. You know, it's what it says, important message. It says work hard in silence. Let the success make noise. And that's very important. Your work will speak itself. Okay. The only thing is you have to do a lot of hard work in your studies, in your learning process, in your research. There's those who say it cannot be done should not interrupt the people who are doing it. So there will be many people who will say that you cannot do this, you cannot do it, but at least they should not interrupt you, whatever you are doing. Great. So, any quick question if you have before we proceed further, ask what you need to ask. Any questions, any doubt, any query? So I think, yes,
Good afternoon.
good afternoon.
May I?
Yes, yes, please
Okay.
go ahead.
Okay. So in case of if the independent variables are continuous and dependent variable is continuous, then with regression we can do the things. But suppose my independent variables are mix of continuous as well as the discrete.
Right.
Then how to do it?
What do you mean by discrete?
Suppose, for example, let's say
Is it binary nature or what?
no, let's say I have taken that, let's say, discipline, let's say, yeah, income level. I have taken 4-5 different labels of the income groups, and
You mean different levels? Say, for
yes,
example,
yeah,
0 to 10,000,
yeah,
10,000 to 20,000.
yes. So level 1, level 2. So I have put it as like this.
Okay.
Yeah, it can be different discipline. I want to see that in different department, what is the employee engagement level. Let's say my dependent variable is employee engagement score. So department wise, I have put it. This is one of the independent variables. So then how to go about it?
Just a minute. Anadi. बस ठीक है क्लास चल रही थी कोई अर्जेंट तो नहीं था कोई अर्जेंट तो नहीं है नहीं अच्छा ठीक ठीक Hi. Yes, Da.
Yes.
Please.
Yeah. So, employee engagement, let's say it's my dependent variable, and my one of my independent variable is
Like
it
this.
it is gender. Another is departments. There are many departments are there
Right.
in the organization. Income levels also are there. Different designations are there, and some continuous data like age, experience. That thing is also there.
Okay.
So that I can put it as the continuous one. But if my independent variables are of discrete in nature, then how to do it?
Then how do we do it?
Yeah.
We do it
Can
by
we?
dummy variables.
Okay.
That's what we are going to discuss.
Right. Okay. Thank you.
The independent variables could be categories, or your dependent variable can also be categories. It's possible.
Okay.
Quite possible.
Okay.
Okay.
Right.
So, friends, I said that we have a simple linear regression model, and we estimate it by using OLS. And we use OLS because they are the best linear unbiased estimator. And in Excel, we use using data analysis. And that data analysis, we use regression. In R, read the data. And you can plot YX. You get a scatter plot, and you can get the regression result by using LM function YX. And then you can see the result, you can see the summary of the result and things like that. So these were the things which we were discussing in the first session. I hope whatever we have discussed so far, we are able to understand.
ऑनलाइन एग्जाम था कि ऑफलाइन ऑफलाइन था तो फिर
Dipesh,
कैसे रुपये आदमी है
2 महीने 11वीं पढ़ा है अच्छे से
Dipesh, so let's see what next we are going to talk about is multiple regression model. So instead of one independent variable, we have number of independent variables. So you have one dependent and number of independent variables. This is your intercept. As usual, these are the slope coefficients of the respective variables. And same assumptions, barring that there should not be any correlation between xi's. Otherwise, all assumptions are same as we had for the two variable model. Zero mean of the error term, constant variance, no autocorrelation, no correlation between x and the error term, and error term follows normal probability distribution. X's are given, and we are assuming all x's are independent of each other. Okay, the method which you use is same, OLS, no different. Yes.
Sir, can you explain the last one assumption?
This one.
Non-stochastic. Yes, sir. This one.
Non-stochastic regressors means x are given. So they don't follow any probability distribution. They're not random. They're not stochastic. They're given. They're non-constant.
Okay, sir. Thank you.
Your error term follows probability distribution. Your Y's follows probability distribution, but X's are not.
You mean
They're
to
not
say they are constant values, sir?
there.
They are constant values? Xi?
Constant value means
Like they are numerical numbers like 45, 60, like that, which do not
Y's are
vary.
also numerical. It has nothing to do with the numerical value. It assumes that all X's are given. So when we estimate Y, we get the expected value of Y given X. So we know X, which is given. And therefore, there is no randomness in X. X is not random, but Y is random.
So we are assuming X as a constant, or they are given as constant?
We are assuming. We are assuming. That's assumption. Think of this is X, this is Y, right? We are given some value of X, say 10. For given 10 X value, you can have different Y's. You may have this, 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 any value of Y. But X is given to me. I know X. But what will be the value of Y corresponding to that given X? I don't know. That's what it means. So we have to determine the expected value of Y given X.
Sir, can we say in multiple regression, the dependent variable has to be in continuous number?
No,
Can we say this is an assumption?
no, it's not. It can be binary. Then we use some different model.
Okay. No, in logistic regression, we use that, yes, if it is binary, we can do it.
Right.
But in multiple regression, yeah, normal regression, so the independent, the dependent variable,
Itika, I think, if I pronounce your name correctly.
Itilekha.
Itileka, sorry.
Yes.
Itileka, logistic regression is also a particular kind of multiple regression model.
Yes, sir. Yes, sir. Okay. Okay.
Particular kind of a regression model.
Okay. Okay, sir. Okay. Thank you, sir.
But you can model it as a regression model.
Okay. Right. Right. Thank you, sir.
And again, I said we will be using OLS estimators, and we have the salary data. And let's see, how do we do it? So again, the process will be something like this. Read the data, make graph, run regression, these are the steps which we are going to follow in R. So okay, so I import file, import data from Excel, browse, we have multiple regression salary data. So I simply are using name as a child. So I have imported this. If you want to see the structure, you can see the structure of it. So we have the average performance rating, experiences, years, certifications, and salary annual. To make a scatter plot matrix, we use a command pair. So if you say pair salary, that's the result which you get. And it's all symmetrical, so no need to get the lower one. So you can say lower panel null, and that's what you get. If you want to fit a line, you simply say upper panel, panel dot smooth, and that's what you get. So this is the relation between salary and average performance. It's a linear relation. And experience in years and salary annual, and certification and salary annual is not that linear. But anyway, we are going to use the linear equation. So the command which I said is pair data salary, and you get it. If you don't want the lower panel of it, you say lower dot panel is equal to null. That means there is no lower values here, which you will see here. No lower values. Then command is lm. So first we have to write the dependent variable, followed by dependent, followed by independent variables. So if you have more than one independent variable, then you have to put plus sign like this, plus. So and then
Sir, can you share the command in chat box, sir, so that we can refer it later on? Thank you, sir.
I put it the command in the chat box. You can see it.
Thank you, sir. Thank you.
So if you run them, that's the result which we get.
Sir,
Yes.
suppose I want to add gender is another column in the independent variable, which is having male, female, and transgender. Let's
Right.
say 1, 2, 3. So with suppose I'm writing that 1, 2, 3. Can I do the run the regression like this? Yeah, I have to do some other treatment for
I
the
told
gender.
you that you have to wait for some time. When
Okay,
we
sure,
discuss
sir.
any variable, I will discuss that.
Sure, sir. Thank you, sir.
Okay, so my estimated model is salary is equal to intercept is 32.92. I'm taking up to 2 digit plus 1.057 performance plus 0.325 experience plus 1.299 certification. Now we have a problem here. Problem is how to interpret the result. What is the interpretation of this number? This number, this number. How do we interpret this? Anyone? Quick, quick, quick. $32.92, of course, means that when performance is rating is 0, experience is 0, certifications are 0, still the person is getting some salary, which is 32.92. If all x's are 0, then y is equal to your intercept alpha hat. And how do we interpret this number? 1.057. Itileka, please come out. Anybody else? Satbir, Rachna.
Sir, these are the coefficients.
These are the coefficient, but what these coefficients are?
Yes, sir, suppose let's say someone is having the salary, let's say, will be calculating if he is having, let's say, 5 years of work experience. So 1.057 into 5, so 32.97 plus 1.057 into 5. So that we do.
No.
I mean, 5 times. So this is the number in multiplied by the x.
No, Itileka, that's not the way we interpret this.
Okay.
Anybody else try?
So it means that whenever person is getting 1 year experience, then
Right.
1.057 is contributing in terms of salary.
In salary with respect to this certification, let's take change in certification. That will be 1.299, this figure. That means if a person is having one more certification, keeping, please understand what I'm saying, keeping performance and experience constant, then his salary will increase by so much amount. It's a partial correlation. Keeping the effect of performance out, experience out, if you increase it by 1 year, sorry, by 1 unit, then 1.299 will be increased in the salary. That's what it means. So if you keep experience constant, certification constant, if somebody gets one performance rating up, then that person's salary will increase by this. That's how we interpret. So when you interpret this coefficient, you have to keep other variables constant. Then you interpret this. Okay?
Right. Thank you.
Then all are coming to be significant. R square is 0.9135 is my R square. Very high degree of R square. R square is high. All variables are coming to be significant. F is also significant. If you see here. That means the model is a good model. Okay. Now I have a problem. I have a model y is equal to alpha plus beta 1 x 1 plus beta 2 x2 plus error. The estimated value is alpha is equal to 9.57 plus 0.58 x1 plus 0.598. I make it 6.98 x2 and assuming both are significant, right? X1 and x2. Which one is having more impact? How do we know? How do we know? And there may be 10 variables and all the 10 variables are coming to be significant, for example. But my curiosity is I want to know which one is having larger impact, which is having smaller impact, given the fact that all are impacting. How do I know that? Anyone? I'm seeing some name. Poonam is there, Nitesh, Sprita, Sivarani, Bharti, Tiwari, Priyanka. So many people are there. Can any one of you tell me, how do I know which one is more significant?
Sir, which is more explained.
More of explain. It's just a guessing, sir. The more the number, so we will say that yes, it is.
Everything is before you. Tell me out of these three, which is having more impact.
So maybe with the help of a t-value.
Okay, so what does it say?
That means experience is having much more impact compared to performance and
Tanaji, right? Yes, Tanaji, tell me.
Maybe experience is having much more impact as compared to performance and certifications.
So should we take lower value or higher?
Higher.
Higher t values.
Sir, higher the value, higher more explained.
Higher t
Salary
value,
experience and years.
more significant, right?
Yes, sir.
Lower p value means what? More significant.
Less.
Because t value and p value, they move in reverse direction. Higher t, lower p value. Lower t, higher p value. Okay, there is another way to understand the comparison. That is, you can calculate standardized beta. When I calculate standardized beta, what does it mean? It means all variables have been standardized. So now they are comparable. Otherwise, what could happen? Some variables are in fractions, some are in thousands, some are in crores, some are in millions. Their coefficients are not comparable. But if you scale them to a same level, then they will become comparable. So I would like to calculate standardized beta. For that, what you have to do, you have to scale your data. How do we scale our data? Let's see. You have to simply write scale before the variables. Scale, scale. Scale of the salary annual, scale of the salary experience, scale of the salary certification, average performance rating, and plus scale of salary certification. Then you simply run this model, get the result, get the summary, and how do we read this? Zero 0.666, 0.249, 0.313 experience. Experience is having higher value, standardized beta, and therefore it has more impact on salary. Others also important, but this is more important. And if you compare the t values, you'll find experience is getting larger value. So there are three ways to compare. One is through t, another is through, p-value, and third is to calculate the standardized beta. Lowest, and my standardized beta is higher in this particular case. And if you want,
Sir,
yes, Tanaji.
sir, can you theoretically explain how can we standardize the variables?
Tanya, how do we get the Z value? How do we get the Z value?
Z value.
Z value.
X,
How do we get it?
X minus Y by sigma. That one you are asking, sir.
X minus
Y by sigma. X minus mu, sorry, X minus mu by.
what is the mean of Z? Mean of Z? What is the variance of Z? It's 1. What does it mean? What does it mean? Yes, yes, please tell me, what does it mean? Anybody? Anybody, what does it mean? When you say I'm standardizing my score, what does it mean? I'm converting all of them
all
Z.
all in one unit.
What is that Z? Because Z is having 0 mean and 1 variance. So all the units are having 0 mean and 1 variance. They are comparable. That's how we standardized it. Taraji, is that okay?
Yes, sir.
Why this is not coming? I think my screen is freezed. Just a minute. I think I have to leave and join again because there is some problem. I'm changing my screen, but are you able to see my change in the screen?
No, sir.
No.
So what I do is I leave and join again. So we move from simple regression to multiple regression where we have multiple variables. Interpretation of their coefficient is change in that particular variable, keeping all other constant, and it represents the partial correlation between the dependent variable and independent variable. And the command is simple. You have to use lm, dependent variable x1 plus x2 plus x3, all independent variable with plus sign. So this is equal to result. Then you can type result to get the coefficient, and to get the detailed summary, you have to use summary result. Okay. Now let's get deeper into the understanding about the multiple regression. You have y, you have x1. If you add x2 into it, what happens? What happens? I have only one independent variable, and that one independent variable is explaining so much of y. When x2 is introduced, what x2 will do? If you introduce x2, what x2 will do?
It will also explain.
It will also explain what portion it will explain.
Yeah, so the R square value will be different.
This part.
Yeah.
That part which is not explained by x1. And anything common between x1 and x2. That will be removed. And that's why we say partial. Please understand it. The moment you introduce x2, x2 explain that part of y which remains after filtering out the effect of x1. Okay. Now I have a question. What is the role of a control variable? What a control variable does? You must have studied and talked about control variable, what they are and why do we introduce them? अरे प्रांशुमन क्या बात है, तुम्हारे पार्टिसिपेंट तो एक्टिव ही नहीं है बिल्कुल, मोटिवेट करो उनको.
So the control variable is the variable which we keep constant during the study.
So what
While
do
we
you
are
mean by
studying,
constant?
so we don't take it as a part of the study, though they are affecting our variables, though it does affect our variable.
Right.
But we don't want to, since it's not the part of the study, we want to keep it constant or unchanged so that we can see the effect of dependent variable on the independent variable.
Okay. So Neha, what is your background? Can you give an example of a control variable?
Sir, I have recently done my PhD on UTAR-2 model. It was on digital financial inclusion using UTAR-2 model.
Okay.
So there I used smart PLS.
What was your dependent variable?
So my dependent variables were, my dependent variable was behavioral intention and usage.
Let me take one, behavioral intention, right?
Yes, sir.
It's a function of what?
So it was P, performance expectancy, effort expectancy. There were actually 7-8 independent variables.
Okay, let me take one. What was your control variable?
Sir, age, gender.
Okay, let me take a simple example, right? So behavior intention depends upon the performance expectancy and age of the person. Okay, why you have taken age as a control variable? Why you are calling it a control variable? Neha, come out. Why you are calling it as a control variable?
Oh, so because that is affecting, but I want to study the effect of performance expectancy on behavioral intention.
So don't include it in the model. Why you should? If you don't want to study, why are you including it?
Sir, I want to check its moderating effect later on. I want to check how it is affecting the relationship of P and BI.
Yeah, that's a different question. My question is very simple. Why should you include age? If I don't include age, so what? If I do not include age, what will happen? Will my result be badly affected by this?
Sir, I won't get the clear picture, the exact results.
But why you will not get clear picture? You will get clear picture about P and behavioral intention.
Sir, but they are affecting the variable. So I want to, I want to keep it constant. That's the reason I'm trying to.
What do you mean by constant? Every respondent has a different age. It's not a constant, it's a variable. It's not same for everyone.
Oh, yeah, you're
Performance
right.
expectation is also different for different people. They are not same. Both are variable.
So, but while we are doing our study, we have certain assumptions. Huh? While I'm making a study, I know that
Tell
there
me
is
what assumption you have made.
Sir, I cannot study the effect of all the variables. There are few variables which are affecting my study. I'm keeping them in count, but that is not part of the relationship which I want to check. I am checking the relationship of P and BI.
Hmm.
And I want to see how age is affecting their relationship then. So later on, I'm doing the moderating analysis over it.
And suppose you don't want to do the moderating relationship, then will you include age or not?
Probably not. But the results won't be the, yeah.
I think the discussion which I had with Neha will give you the issue which we have in hand. And when we talk about multiple regression and through this Venn diagram, you can make out what exactly we're talking about. Because the behavioral intention which we have, some part of it is explained by age. But age is not my variable of interest. I don't want to study age, but age is impacting my Y. So what should I do? I should filter out the impact of the age from my Y. Whatever is left, that you try to explain by your variables of interest. And that precisely multiple regression does. Okay, I repeat what I'm saying. You have Y. X1 is your control variable. So X1 is explaining this part. But this is not your variable of interest. You have to filter out the effect of the X1. Then, whatever is left, this part you would like to explain through your variable of interest. So variable of interest will explain only this much. Yeah, that's the motivation for me to introduce the control variables.
Yes,
Because
sir.
I am trying to filter out the effect of control variables from my dependent variable.
Yes, sir.
Whatever is left, that I try to explain through my variables of interest. Okay, regression model doesn't know what is your variable of interest and what is your control variable. Regression doesn't know. Who knows? You know that. What is my variable of interest? What is my variable of control? So friends, multiple regression helps you in filtering out the effect of the variables. And then whatever is left, that you can explain by using your variable of interest.
Right, sir.
So this area is explained by x1 of y. And if we add x2 into it, what happens? This area is already explained. So x2 will explain that part of y, which is this one. And then x2 is explaining this part. And whatever common is there between x1 and x2, that will be removed. So basically what you are doing, you are regressing the y minus x1 with x2 minus x1. So this is x2 minus x1, and the whole is your y minus x1. That's what you're regressing. So basically, multiple regression helps you in filtering out the effect of the variables and then study it. Will the whole of x2 explain the residuals of y? No, only that part of x2 which is not contained in x1. This part of x2 which is not contained in x1 will be explained, and that explained part is this much of the y. So estimate y, estimate the residuals. Remember that x2 will explain only the residuals of y. And then you regress x2 with x1, remove the filter out the same, and then regress residuals of y with filtered values of x2. And then you get the result. So friends, you have to be careful about multiple regression. Multiple regression, what it does, it filters out the effect of other variables. And then give you the relation between a variable and your y. So if I write regression, y is equal to alpha plus beta 1 x1 plus beta 2 x2 plus errata. So effect of the x1 will be filtered out. Whatever left residual, that will be explained by x2. And this understanding, I tell you, is very, very important to understand moderating effect, mediating effect, control variable effect, all those things. Now, what is the difference between a control variable and mediating variable?
Yes, sir. The difference
Control
between
variable
control.
and mediating variable.
So mediating variable is a variable, like in my study, behavior intention was a mediating variable for performance expectancy and usage. So it was there. It was affecting usage, and it has a direct effect also, and P was indirectly affecting also usage through behavioral intention. So behavioral intention in that case was a mediating variable. And control variable is something which is affecting but which is not part of the study, and we're filtering that part of it out of it.
Okay, so I think
Sir,
since you started discussing it, let me
sir,
give. Yes, Rachna.
sir, if we in this equation, if we include gender also as a mediating variable, the same behavioral intention equal to P plus beta
I
2A,
don't know whether Neha is
and
introduced.
it is a mediating. We are including a one variable to balance between the independent dependent variable.
I have some data, which is BP data. Oh, CSV. And, okay, it's a CSV file, so I have to read it using CSV. I just read a file. If you want to see the structure of it, you can see the structure STR, PP. So we have age, we have weight, we have PP. Okay, so I run model 1 LM PP H. Oh, sorry. I have to attach the file. Data equal to yes. Now we see the result summary. I have a question here. My age is coming to be significant. Age is R square is also 61%. F statistics is also significant. Is this model a good model? Where we have BP is equal to 10.39 plus 2.86H. Is this a good model?
No, sir.
Why, Rachna? Why it's not a good model? My R square is very high. My variables are coming to be significant. F is coming to be significant. Where's the problem?
Because the variable age is not totally explained by the independent variables.
So what should we do?
So you have to apply the moderator here to
Moderator, what is moderator here?
explain the process two variables are they can be explained.
What is moderator here? What is moderator here?
So BP,
BP is dependent variable.
oh,
Yeah, tell me moderating variable here. I add into weight.
WT is a moderator.
So my age is becoming this one. Weight is this one. This is my R square. So I have two models with me, model 1, model 2. Model 1, BP regress with age. BP regress with age and weight.
So moderating है.
Moderating. Why it's moderating?
No, sir, ये तो normal independent and dependent variables है ना? I mean, have we taken age as a moderator here? We have taken it as an independent variable na, for BP.
Right.
So moderator तो हमने लिया ही नहीं है ना अभी.
कैसे पता तुमने नहीं लिया मैंने? How do
No,
you
sir,
know?
I'm asking because I don't know the
Good, how do you know?
No, sir, I'm asking that have we taken something as moderator?
Okay. Sorry. Think it is okay. So age, sorry. So my age is impacting BP, right? Isn't it?
Hmm.
And my age is impacting weight. And weight is impacting BP.
Yes, sir.
Now tell me.
So, sir, weight is a mediating variable then, na?
Mediating or moderating?
Sir, mediating.
Are you sure?
Yes, sir. Moderator check the strength of the relationship between age and BP. So we are not doing that.
Partial moderating या partial mediating है.
हाँ,
Complete.
complete नहीं sir, partial mediating, but it's a mediating variable.
तो इसमें direct effect क्या है और indirect effect क्या है?
The direct is age और BP का relationship या weight और BP का direct relationship.
This
Yes,
is
sir.
indirect.
Indirect. So weight is the mediating variable for age and BP's relationship through weight जब जा रहा है.
So do I need SAM for this purpose? I can do it in regression.
So we can,
Regression
but
is more powerful.
yes, sir. Actually, I worked on Smart PLS because my model was very complicated and the model was earlier worked on PLS only. So I chose Smart PLS for the same.
Okay. You know, friends, what I'm trying to say is what variable should be taken as a control variable, what variable should be taken as a mediating, moderating. Multiple regression doesn't make any difference. It is you who have to understand, it is you who have to interpret the result accordingly. Okay, so that you can decide yourself. So multiple regression is a very powerful tool, helps you in modeling so many things, and at the top of it, it allows you to check for the assumptions. Now you cannot test your assumptions in SIM, but in regression you can do that.
Yes, sir.
Anyway. Friends, any question about multiple regression?
Sir, I have a question.
Yes, Rachna.
Sir, what is multicollinearity?
Multicollinearity.
Yes, sir.
ना उसके लिए तुम्हें वेट करना पड़ेगा थोड़ा. We'll discuss it. So let's continue with our, this is what I was discussing with you, and the model which we got is like this. So the age is impacting weight and blood pressure directly and indirectly through weight. And you can easily calculate the impact of the weight and that you can do by using the regression analysis. This is the direct impact. This is through weight. You know what is the interpretation of it? If a person age is increasing by 1 year, keeping weight constant, then this is the impact on blood pressure. But if we don't keep weight constant, then the impact will be 2.161 plus 1.431 into 0.490. This is direct and this is indirect effect. And that you can easily do by using the multiple regression. Can I increase the value of R square by adding more and more values, variables in my model for get a better model? Because we always like to have a model with higher R square. So if you go on adding variables into your model, will your R square increase? नेहा तुम बोलो R square बढ़ेगा घटेगा?
Yes, sir, it will be increased when we are adding the variables.
Model 2 is better. Yes, till adjusted R square starts decreasing. It may not be. Okay.
The goodness of model will be more.
Okay, so
Sir, the answer is yes.
always yes. It's Lekha, always yes. Not a question of may or may not be. Whenever you increase your R square by adding variables, R square will always increase. So does it mean that your model is a good model?
Not necessarily. Not necessarily.
Why it's not necessary?
Because if the adjusted R square starts decreasing, then we should stop at that moment of time to add the
Why should
more
we go for
variables.
adjusted R square?
Because it is not adding value. The addition of more variables into the equation will not add much value to the model.
So adjusted R square tell you how much value is being added.
Because if we keep on adding, then at certain point of time, adjusted R square will come down. Then the R square value. So at that point of time, we should stop.
If I adding, Ravi is saying if I adding variable of 0 number of times, then it's work or not. I don't know. Ravi ji, I'm not able to understand what you're saying. Satvir ji, very fundamental principle you have to remember.
Yes, sir.
There is no free lunch. If somebody is giving you benefit of getting higher R square, do you know what is the price you're paying?
Yes, we have to spend more resources on getting data. Yes, sir.
No.
For exploration of additional variables, we have to spend money.
That's not thing. You have the data.
Sir,
If you see your R square increasing, It doesn't come free of cost. You are paying some cost. What is that cost you're paying? Yes, Rachna.
Sir, more,
Ravi
more,
Sharma,
more, sir, more the R square, more it can be explained by the model. If the R square is increased, it means the most of the variables which has been included in the model are mainly explained by the independent variable, predictor variable, in contrast to the dependent variables. So, in the model, the fitness of model goodness will be increased. It will be fairly good.
Rachna, everyone would like to have higher and higher R square. It doesn't mean that that person should go on adding variables.
You are not audible. Yeah.
If you are adding more and more variables into your model, what is the price you are paying?
Not more and so see sir, it is depend upon the objective as well as
No,
the
Rachna, it
equations
doesn't
here.
depend. Rachna, it doesn't depend upon anything. What we lose is there is a loss of what? Degrees of freedom. That's my loss. Higher the number of variables you add, you're losing your degrees of freedom. And if you lose your degrees of freedom, your quality of estimate will be under a question mark. So it doesn't make sense to go on increasing your variables to enhance your R square. It has to be seen vis-a-vis with the loss of your degrees of freedom. And that vis-a-vis with degrees of freedom can be understood by another measure of R square, which is called adjusted R square. That is R square, which is adjusted for degrees of freedom. See here, these are the degrees of freedom of the residuals and the total. So adjusted R square compare the explanatory variable vis-a-vis with the loss of the degrees of freedom, and then tell you whether you should add more variable into your model or should you not add more model. So let me summarize what I say. Adding more variable will always increase R square, always, without exception. But when we calculate adjusted R square, it may be increasing सतवीर जी ऑफ करो अपने आप को अनम्यूट करो म्यूट करो so adjusted
yes sir
adjusted R square is used where we use adjusted R square. We use adjusted R square to compare models. Should you have 4 variable model, 5 variable model, 6, 7, like this? How many variables model you need? That will depend upon adjusted R square. The model which gives you the highest adjusted R square, that will be the preferred model. So adjusted R square helps you in selecting model with different number of variables. And please understand, R square is still representing percent of explained variation. Adjusted R square is not percent of variation explained. So if you have to give the interpretation of percent of variation explained, it should be in terms of R square. For comparison purposes of the model, same dependent variable, but with different number of independent variables, then we should use adjusted R square. And adjusted R square can be negative. That's quite possible. And if it adjusted R square is negative, that means your model is not acceptable at all. Either you change your variable, change your data, increase the data size, whatever you do, you have to make sure that adjusted R square is, positive. It's not negative. What next is something which we have to look at. Look at this. Suppose we are doing CVP analysis, and I hope many of you must be aware of it. And we need to bifurcate variable cost with the fixed cost to get the break-even point. How can we do that? How can we do that? If I run a regression model, total cost is equal to alpha plus beta quantity plus error term. What is my alpha? Anyone? अरे तुम लोग क्यों नहीं बोलते हो? सतबीर, इतिलेखा, नेहा, CVP,
cost of raw material.
Variable or fixed? Ravi?
So fixed.
Alpha gives you fixed cost. Because even if your quantity is 0, your total cost still gets a cost which is alpha, fixed cost. And what is beta? Ravi, what is beta?
Beta is other expenditures
Beta is your variable cost.
to be going for a finished product.
Beta is your variable cost.
Yes, variable cost, because define not how much expenditure to be a finishing products to be.
Yes. Suppose we are trying to find out the variable cost and the fixed cost of the model, and we come across with this kind of a behavior. What's the challenge here?
If cost of investment, cost of raw material is lower, then if you are changing your expenditure, like to be improvement your product to finish, like adding other expenditures to give a finished product in different ways, then have to be challenges to increase or compete to other products in variances.
Ravi, this is my total cost. So I do not know how much is my material cost, how much is my overheads, how much is my labor cost. I don't know. It's my total cost. So I cannot comment anything about material things.
Sir, actually, whatever cost we have to be accorded, we know about that, how much we have to be expenditure in a particular product. Then we have a differentiation between two different lines.
Variance is an issue.
Hello?
Variance is an issue.
What is the issue, Neha?
I'm just trying to guess. Variance is an issue.
Variance, which variance? Are you talking variance in terms of the standard costing or what? Statistical terms.
So variance among the when I see the plot, when I see the scatter diagram, when they are very close, that means all the terms which we have taken are pretty close to our main average. But when these diagrams are scattered, it means there is a higher degree of deviation. The variance is higher here. I mean, this I can actually.
Okay. Suppose I fit
trying
it,
to understand.
if I fit a regression line, I may get a regression like this. And for the second one, I may get a regression like this.
Sir, we can say, can we say that the beta is changing beta is different in both the data?
So beta is
Variable
the risk,
cost
no?
here you have,
Beta is the way.
and the variable cost which you have here, they are different. Here we have low variable cost. Here we have high variable cost. So the slopes are changing. Intercepts are also changing, if you see. I mean, how to model such kind of a problem where we find different behavior for different values. How do we get that? Suppose I have data like this. I have data like this. This is for
Sir, we have to make clusters, sir.
how to take care of it. Behavior of male is different from behavior of the female. Suppose we are taking salary here. So do you think gender has an impact on the salary?
Yes, sir.
How to model it? Itilika, I'm now taking your question. Okay.
Yes, sir. Yes, sir. I'm looking forward to it.
Moderator analysis.
No.
But nowadays, sir, the salary part for male, which will return, I think it should be female, and the lower bottom data, it should be for males.
भैया तुम जो करते रहो.
It's an hypothetical example.
सतवीर को दुख हो रहा है या खुशी हो रही है? Okay. Suppose this is for the income group between 0 to 10,000, 10,000 to say 50,000, and above 50,000, right? So their behavior is totally different. How to model it? That's a question which we have. That means if you have some categorical variable, qualitative variable, and you want to make it as a part of your model, how can we do that?
So multi-grouping analysis?
Huh?
If we group them, multi-group analysis, we take out the data for two different groups and compare them?
No. Yeah, this is regression. This is not T-analysis, T-test. So the mean logistic regression is used when your dependent is binary. Here my data is not binary. So have you ever wondered how to estimate the gender bias in the wages in India, impact of the booms and recessions on the debt of the companies, and the impact of the market volatility on the risk? Or do we know that? Now you give me all categorical qualitative data. You can model it by making use of binary variables, which we call them as dummy variables. So researchers often come across with binary variables, categorical variables, qualitative variables, nominal variables. And to model them, we use dummy variable or binary variable in our regression. They are useful to handle cases when we have to introduce qualitative variables and the observations are different for different cases. Dummy variables can impact your intercept, can impact your slope, or may impact both slope as well as intercept. So when dummy variables are entering into our model as intercept, y is equal to alpha plus beta x plus beta 2 dummy plus error term. Look at this model. Please note this model. Where you see the impact of the dummy. Is it on the beta, the slope, or is it on the intercept? And we know that dummy variable d can take a value 0 or can take a value 1. If it takes a value 0, y is equal to alpha plus beta 1 x plus error term. If it is 1, then what happens? Y is equal to alpha plus beta 1 x plus beta 2 plus error term. Beta 2 will be clubbed with alpha. So we get y is equal to alpha plus beta 2 plus beta 1 x plus error term. So that means my intercept is impacted. There is no impact on the beta 1, but my alpha is impacted by the amount of the dummy variable. So when you introduce dummy like this, it impacts your intercept. Like here, this is impacting my alpha. Another case may be when you are believing that the slope will change, then you have to multiply x with dummy variable. What does it mean? It means the following: y is equal to alpha plus beta 1 x plus beta 2 x into dummy. So if dummy is 0, what happens? Y is equal to alpha plus beta 1 x. And when dummy is 1,
the slope will become beta 1 plus beta 2. Okay.
Alpha plus beta 1 x plus beta 2 x plus error term. X is common, I can take it outside. So we get beta 1 plus beta 2 x plus error term. That means my dummy is impacting my slope. And if you have added a dummy, multiply a variable with a dummy, this model will impact your intercept as well as your slope.
So, sir, this model is combination of previous two models, right, sir?
Yes. Where it is impacting my slope as well as my intercept. Italica dummy variable is introduced as a binary variable because it gives you value when it is 0 and when it is 1. If you take a binary variable 1, 2, 3, then if you take variable like 0, 1, 2, 3, 4, then regression will not be able to understand whether it's a dummy variable or actually a variable. So to distinguish it between the real variable, which can take discrete values, and the actual variable, we always, the qualitative variable, we introduce dummy variable 0, 1. So if it is 0, I know what is the impact of it. If it is 1, what is the impact of it? So that you can understand.
Okay.
Qualitative means what? Either it will present or it will not be present.
Okay, sir, suppose let's say gender. So I have, let's say transgender is also one, male, female and transgender. So then in that case, how to do it?
We have to introduce 2 dummy variables in that case.
Okay. Right, sir. Right, sir. Thank you, sir.
Okay. So we can draw the graph and make the models and fit the regression lines as per our model. Okay. And that's the graph you will see. Where we can use dummy variables, where you have qualitative variables like rural, urban, young, old, numerical factors like age groups, income groups, proxy shift in the function over time, and proxy for seasonal adjustments in a time series or particular event in your time series. And do dummy variables hit us? Yes, that's called dummy variable trap. What is the dummy variable trap? Itileka, I ask you the same question. You have male, you have female, you have a transgender, right? Why I'm not introducing three dummy variables? One for male, one for female, one for transgender. Why I'm not introducing 3 variables, 3 dummy? Why I said 2? Any one of you can imagine?
Sir, actually, one variable has to be taken as a real variable. At least one out of these 3 variables, at least one has to be taken as real variable, and dummy variables we have to add for comparison purpose.
All are real. Males are real, females are real.
But for modeling, sir, we have to
binary calculations.
make the model by adding 2 dummy variables, no, sir?
But why not 3?
So because only
Then our there will be effect on alpha value as well as slope value then, sir.
Because we are doing it like absence and presence of a particular data. So 0 says absence and 1 says presence. It's in a we are doing it in binary terms.
That's not the issue. Ravi,
I think the moment
or R cube, nothing to do with that.
Sir, is it that the moment we are going to put, let's say for transgender 2, then while doing it, might be the computer will think it is a continuous data, 0, 1, 2, 3, no?
Because I mean, computer doesn't know. Computer know only 3 variables. All are binary.
Because we are doing it in binary terms and we are just telling about the absence and presence of things.
Yeah,
so
it's
one
not
represents
like
the yes, sir.
It's not like that. You just think if I add what I get. What I get.
1.
So what does it mean? You will not
It
be able
will
to,
mean only one variable then.
Satvir ji, you will not get a solution.
Yes, sir. It will give only some
Will create a
confusion.
determinant to become 0. So you won't get a solution. To avoid that solution problem, we always take number of categories, one number of dummy variables, always. Otherwise, you will be caught in a dummy variable trap and you will not get the solution. Now it will be 1, 0, 0, 1. It will not be 1, 1, 1, 1, 1. Since if you introduce all the three, the sum total will always be 1 and you will not be able to get solution. That's the reason we should not add unit. We should not add the variable. We should always add less than one number of dummy variables. Okay. So, Itilekha, how many income groups you have?
Sir, 5.
So you have to introduce 4. So
Okay.
if you introduce 4, 1, 2, 3, 4. What does 0, 0 means? What does 0, 0 means? Your 5th category.
Yes, sir.
This is first category, this is second, this is third, and this may be 4th. All zeros means 5th. That's how you have to read it. Okay. So, Ranchuman,
Yes, sir.
break for the lunch practice, I will take later on.
Yes. Sir, how much break we should give? Because as per the schedule, 30 minutes break to be given. But
Meet at 3:15, right?
it is 2:30 right now. So
3:15.
3. Okay, 3:15. Okay.
Right,
All right. So participants, we will meet at 3:15 for the third session.
तो
Thank you, sir.
energy
And,
को
sir,
शक्ति को तभी तो आगे जाके काम करेंगे ये लोग.
yes.
Thank you, sir. Thank you.
Participants, please remain in the session till then. Thank you.
ये रखो। मैंने सामने वो खोल दिया, अंदर का दरवाजा थोड़ा खुला है उससे। अगर आएगी तो करना। अभी तो इसी की चल रहा।
Can we start? Hello. sir. Hello.
Yes,
Hello. Yes, sir. So, shall we start, sir?
this is I'm
Fine.
ready.
Okay. So, I, Dr. Nishya Kumar Upmanyu, welcome to Professor C.P. Gupta, sir, and all the participants in the third session of today. So, sir, you can now you can proceed the session. Thank you very much.
Okay. So let's start. It says, welcome you to be here to teach us sure about virtue. Values we hold on your command. Your love shines in each word. And that's a prayer to the God. It says your love shines in every word, and that's true. And it said the best insurance policy for tomorrow is the make the most productive use of today. And friends, there is no substitute for hard work. And the more productive you make today, the more result you will get in future. So let's start in the spread positivity, and I hope you are all back with a lot of energy and a lot of enthusiasm for our coming sessions. Okay. So friends, welcome you again and welcome back. Good afternoon to all of you. It says we remember 20% of what we hear. We remember 30% of what we see. We remember 50% of what we see and hear. We remember 90% of what we say and do. And that shows emphasis on doing the things. I hear, I forget. I see, I remember. I do. I understand. So we are going to work with the dummy variables. We didn't have the practice of dummy variables before the lunch break, but we are able to cover the theoretical backdrop of dummy variables. It said today is the day to learn something new and make it a point that at the end of the day, we are definitely going to learn something new, something which you were not aware of when the day started. Never doubt your abilities. For a moment in life, wish you good luck and all the best to all of you. Enjoy, have a good time. But before we discuss something important in econometrics, so let's go to R and take up some problems. But before that, if any one of you have any question, any doubt, please let me know.
Participants, if you are having any doubts,
Any questions? Okay. I'm using database from Woolridge book. So for that, we have to install a package called Woolridge. And then from that installation of the package, we have to download that library, Woolridge. And data is saving. Data is in the name of saving. So it's installing the package Woolridge. Woolridge is a well-known person who has written a good book on econometrics and uses some database. And we are picking one of the database from that particular whole database of Woolrich. So we install the library, we fetch the data saving, and if we see the structure of if you want to view the data, you can view the data. So we have saving, we have the income, family size, education level, age, and whether we have a person with black background or non-black background, and we have the consumption. If you want to see the structure, you can see the structure. So we have saving, income, size, education, age, black, and consumption. I attach it and I can draw the matrix. And if you don't want the lower part, you can simply write lower panel lower dot panel is equal to null. Okay, I have to put it in inverted commas. So just a minute. It's not coming like this. Just a minute. Lower dot panel. So friends, just a minute. over dot random is equal to null. So should be capital. That's the graph which you can see showing the relation between, I think, let me increase the size. And you can see the relation between different variables which we have. So black is the dummy variable, and you can see the relation between them. Okay. Then so if we wish that the impact, I'm taking income and the dummy variable. So LM save for saving and tilde INC plus black. So when you put plus black, that means we are running dummy variable, which is going to have impact on the intercept. So I just run all of them. And we see so plot income with the predicted dummy variable saving. Black factor is for dummy type P. Color, if saving black is equal to 0, then it should be red, otherwise it should be 1. And you can see both the lines are coming to be almost parallel. And if we see the impact on the slope, then we have to multiply dummy variable with the variable of interest. So I run, that's my dummy, and that's my interaction term. Okay, so it gives me both the intercept as well as the interaction. But let me check if I want only this. I just want for the slope, not for the intercept. We have to put a plus sign. Friends, I'm not able to get these only slope. Only slope. If I just write this, let me check what we get. Plug interaction with income. I don't know how to get only effect of the black on this slope, not intercept as well as this slope. If I run the next module, it's also giving me the same result. Friends, give me a minute. We get the impact of the black. So friend, I really don't know how to separate, how to get the impact of the slope only. It giving you the impact of the slope as well as the and that the plot, if you see the plot carefully, you'll find the slope is impacted along with the intercept. So my intercept is impacted. My slope is also impacted. This is negative intercept. That shows up if you take only black people, they have negative saving. But if black people are having higher salary, higher income, then they're likely to save more. That's what it says. This is your interaction between the income and the black, which we have a dummy variable. And if I read my cost data, let me read my cost data. I show you where we have that. I see here. So let me read my cost data. Then I will show you what is it and how we can model it. So I import from Excel. Browse data bias regression. The data which we have is cost data. That's what I am naming it as. So we have the quantity produced, we have a dummy, we have a total cost. If I make a plot of it, so this is the structure of the cost data. We have quantity produced, dummy, total cost. You can see the tail, head data, head data. Let me attach it. And cost data. So Okay, quantity produced. Quantity produced and total cost is now you can see here we get two different and this where we have defined a dummy. And dummy is impacting my slope plus intercept. So I clear geometry. If I put here quantity produced, total cost, then you, if you want, you can have the different colors. Cost data. Dummy. If it is 0, then we should get blue, otherwise we should get red. Now you can see here. Two different phases you will find which exist here. And for that we can put a line. So my total cost versus, if I don't consider my you know dummy, let's see what result we get. Quantity produced, that the result which we get, and this is the summary of the result which we get. I can make the line which is
Correct?
hello.
Sir, excuse me, sir. Actually, participants are asking about the RScript file or the command for dummy variables.
I will share with them. Isha, I will share with them.
Yeah, sir, please.
I will share with them. The This is the fitted line when we have regression without dummy. And if we have regression with dummy, let's see what line we get. So I take total cost. Quantity plus dummy variable and this is when we have the intercept. But if you want slope and intercept both should change, then I just copy it from here. Color green and so if I want the interactions, what I do is I multiply my quantity produced with the dummy data.
The multiply means interaction between dummy data or the
Yes.
okay.
Interaction with the dummy data, that means the slope will be affected. The slope will be affected by this.
So how it can be interpreted in the result?
I just take the output and then interpret it. Instead of making graph, I make the output. I just copy it from here. One equals this. Summary. So I run it. I think I must write it somewhere. I'm copying it to a Word file so that we can easily interpret the results.
एक मिनट रुक जाइयो.
Because you are muted. No, just unmute.
Yes. So my input, my model is like this. So we have a cost that's equal to this is raise the power 5. So this will be a very big number 108000 plus this is raised to the 4. So this will be 35140. Sorry, this is the standard error. And this is dummy, which is negative. Minus 1.0001625 plus 36.33 quantity into dummy. This is quantity. And sorry, I think I missed. This is dummy. I missed one number. And this is 50.5 quantity. Okay. Now, Rachna, I share with you the commands. So I've shared the commands and how do we read it here? Let's look at this. And this is my cost function, where alpha is my fixed cost, beta is my variable cost. So this is my fixed cost. This is my variable cost. If dummy is 0. If dummy is 1, you know what happens? This is negative. Your fixed cost has come down. But your variable cost will go up because that will be added to your slope. So this is how we can interpret this. So we have a dummy here, quantity, dummy here. So when after that change, fixed cost has come down, but my variable cost has gone up. And you can see it from the graph as well. If I show you the graph, then you can see the red one. Fixed cost is going down. But since slope is high, my variable cost is high. When we have dummy equal to 1. Let me take one very quick exercise. Let me have a new. So I open a file, import from Excel. Browse data files, regression files. We have the wage data with dummy. So I just take wage data, simply wage, the small. So we have the wage, we have the education, we have the experience, we have whether the people are married people or unmarried people. I don't want to open it. If you want to see the structure of wage, you can see the structure of wage. So we have wage, education, experience, and married. Whether a person is married or not, that's a dummy variable. So I run the regression. I say model 1. That's equal to ln. So we have wage dollar wage education plus wage experience plus wage whether the person is married or not. And if I want interaction, I should multiply it by, what do you think? Education.
Education.
Okay. Let me take first simple model. So, summary model 1. So, what does it mean? How do we interpret this?
Model is significant, sir.
And this is significant. Education has a positive impact, experience has a positive impact. Education has significant impact because G value the highest. What do you say? Who gets salary?
Interaction between
Married people.
wage and
Sir, experience is more significant, no, sir?
Huh?
Experience is more significant, no, sir?
P value is 14.913. Experience has a lower value.
For T, I was seeing the P value of for experience. It is coming to be 8.7 raised to the power minus 6. Okay.
And this is
Yes, sir. Sorry. It is minus 16 for education. Right, sir. Understood.
so that this positive number means married people get on an average higher salary of 2.00711 as compared to female.
Sir, can you please explain once more, sir?
Married. 0 means female, 1 means male. Sorry, 0 means unmarried, and 1 means married. So if it is 1, this will be positive. What does it mean?
Means married people have.
Married people get more salary as compared to unmarried people.
Yes.
Do you see any interaction between any variables? When I say interaction, that means the slope is impacted. A person which is having more experience and married, let's see what happened to that person.
So now it has gone to minus 0.0.
With experience. So that means a person with a higher experience and merit person, he will be penalized because coefficient is now negative.
Yes, sir.
That's what it means. Sorry.
Sir, in yesterday's lecture, an example was given of Mr. Virat Kohli. His performance after marriage has gone down. So this table is also showing that experience plus marriage is being penalized.
I'm not getting the options of Zoom. Where are those options gone? Anyone? I think some problem is there because if I close it, the moment I put it here, my screen is freeze. I don't know why.
So you can use the share screen once again. In the bottom.
Yes. Now it's good. Why it was stopped? So that's how we can, look at the dummy variables. In what context you had a discussion on dummy variable? होली का example क्यों आया था? किस context में आया था?
No, actually, I was just joking. Yesterday in one lecture, he showed the data.
To what?
He showed the data. He was comparing the performance of Virat Kohli before marriage and after marriage. Okay. So he was giving a visualization lecture.
Okay.
So the performance had gone down after marriage. So in this case also, if experience and marriage is clubbed together, then it is not giving significance.
Satbir, you have been given the visualization, right?
Yes, sir.
Performance has gone down.
Yes, sir.
Visualizations are deceptive. We don't accept the results of visualization.
Okay.
But we don't accept unless and until we statistically check.
All right, sir.
It may be random.
Mm-hmm. But here, in this case, we have to, we can justify it by statistics in this case.
Yes. Ultimately, we have to prove it by statistics.
Yes, sir. Yes, true, sir.
Whether there is statistical difference or not. The graph, you can change the dimensions of the graph, scale of the graph, expand it, reduce it. You can do a lot of things with it. Visualization is also innate, nothing else. Ultimately, you have to prove statistically whether you have significant difference or not.
Thank you.
So, I put my last commands here. So like this, you can attempt different dummy variables into your problems and run it. Okay, any question about dummy variables?
Sir, I have one question.
Yes, tell me.
Sir, I would like to know that in which condition we have to decide that now we have to introduce a dummy variable in our equation.
Right.
If there is any.
Yes, Rachna, whenever you come across with qualitative data, categorical data,
Right,
there
sir.
you can use dummy variables.
Right, sir.
Okay, like gender, age groups, income groups, background, rural background, urban background. There you can make use of dummy variables.
And then my second question is while writing the interpretation of the results which we have get from this last command, sir, what are the main specific table? What are the main things we have to be focused, like p-value, estimated error?
So we have to look at the p-value, whether the dummy dummy coefficient is significantly different from zero or not. If it is coming to be significant, that means dummy variable has an impact.
So if there is any negative value, then what it signifies?
It's negative. It's pulling it down.
Okay, sir. Thank you.
So friend, let's move further and important things which are going to discuss. Can you imagine who is the best friend in econometrics? Can you imagine who you will always wish to have it in your toolkit? Because that is having very nice properties. And that best friend is my OLS. And why it is my best friend? Because if I use OLS, I get the best estimates, blue estimates. But the condition is my assumptions are true. If my assumptions are true, OLS will give you the best result. And you should always go for OLS, nothing else. But if assumptions are not true, then OLS will not behave as expected and you will start getting problem. And it might be possible that your estimates are no longer blue estimates. Okay, so whenever you do regression analysis, you have to always check for the assumptions. So we have to think what assumptions are volatile. Let's quickly look at the assumptions which you made. Error term mean is 0, variance constant, no autocorrelation problem, and covariance between x and the error term is 0. Normality and x's are given, and we don't have any collinearity between them. What happened and what are the consequences when we see these assumptions are violated? Mean of the error term is not 0. Distribution is not normal. Variances are not constant. Correlation exists among error terms, and we have multicollinearity among independent variables. So when these assumptions are violated, what happens? So the challenge is how to know whether the assumptions are violated. What are the consequences if the assumptions are violated? And how to take care of those problems. That will be my sequence of discussion. So starting with what if my error term does not have a 0 mean? And in this case, you have to save your residuals. So the command is residual. So residuals, model 1. Sorry, I have to save the residuals. Suppose I save in res. Can you imagine what will be the mean of residual? Anybody guess? What will the mean of the residual? Anybody guess?
0, sir.
Why 0? There are chances that the assumption may be violated.
Okay, sir.
It's 0. Satbir, don't forget my initial comments when I started it.
Yes, sir.
If you understand, you can explain it simply. If you don't understand, you cannot. If you take mean of residuals, it will always be 0. Provided, that provided is very important. Provided we have alpha or intercept in the model. If you run a model without intercept, there is a possibility that the mean of the residual may not be 0. And can you imagine how to estimate a model without residuals? Sorry, without intercept. I think I have still result 1 ln if you write -1, that means you want the result without intercept. Capital Y. And if you see the result, it will be without intercept. If you see the summary, so if you take now the mean of the residuals, it's quite possible that it may not be, its mean may not be 0, quite possible. I'm not saying it will be 0, but it may be possible that it's not equal to 0. So we have to estimate residuals. Let's call it 2 residuals of result 1 mean of residual. Do you see this mean 2.07? So you have to be careful. If you use intercept, the value of the mean of the error term will always be 0. Otherwise, it may be 0, it may not be 0.
Well, if residual is 0, then what we should consider? That means there is no error in our model.
This is average. Some errors are positive, some errors are negative, but on an average, it's 0. So when this assumption is violated, that means the expected value of the error term is not 0. If the model does not have any interceptor, then the violation of this assumption quite possible. And if it is violated, then your results will be biased results. And if the estimated model is having intercept, then there is no need to test for such violation, as this violation will never happen. But if the model is having no intercept, then we can simply perform hypotesting with null hypothesis. The mean of the error term is 0, and you can use t-test. And that's the reason we always suggest people use model with intercept. And if you use this model, any model with intercept, the assumption of expected value of the error term is 0 will never be violated. Okay?
Yes, sir.
Error term does not follow normal probability distribution. That's the second violation. And if your error term doesn't follow normal probability distribution, what will be the consequences? Not follow the normal probability distribution. The consequences are that we may not be able to use t-test, f-test, chi-square distribution for hypotesting and interval estimation. Our estimates will still be blue. No problem with my estimates, but problem will be with hypothesis testing and confidence interval. How do we deduct it? We can deduct it through graphical method, or you can take the basic statistics. See, the skewness is not equal to 0 and kurtosis is not equal to 3. You can make QQ plot, you can make histogram. These two are graphical, and you can make use of KS test and Zerich-Bera test for testing normality of the distribution. That's how we calculate GB test, which is based on S skewness and K kurtosis. Follows chi-square distribution. Okay, so let me show you how can we do this. So we have to first load a library which is called fbasics. And then we can make a histogram. But we have to get the let me read a file, sales and advertisement data CSV. So prestige data files. So we read the file and the output is stored in data. If you can see the structure of data, that's the structure data frame. Okay. I have to check what is that file. Oh, it's an Excel file. It's not CSV file, it's an Excel file, so I have to import it through Excel. That's why it's showing the problem. So I go to File, Import Data Set from Excel. I take it, data. So browse data files, regression. Data file. Data. Now we can see the structure of the data, sales price and advertisement. I attach. So we have the sales, advertisement and the price data. I get the output one. This is the summary of the output. So advertisement expenses, prices are significant, but advertisement is having positive impact on the sales, but prices are having negative impact on the sales. Significant. R square is positive. Adjusted R square is also positive. F statistics also coming to be significant. That shows model by and large is a good model. Then we save residuals and predicted value of the output 1, then loading the library F basics. Then I can make the histogram with the normal curve. Like this. So it shows that peak may be higher. It may have higher curtices, and that may hint that the distribution is not a normal distribution. We can make QQ plot. So we plot suppose I take a variable I take predicted variables. Predict value. Just a minute. Just checking with the QQ plot command. Just give me a minute. This is not QQ plot, this is QQ norm. Let me see how can I draw. Just keep it, then I can draw the QQ line. It shows that at the end, lower probability as compared to the normal distribution towards the left-hand side of the distribution and higher probabilities towards left-hand side of the distribution. By and large, it's quite normal. So it gives an idea that distribution may be normal distribution, which we have to look at. Then we have the Zarek-Vera test for resident. P-value is 0.9236. That means distribution is a normal distribution. We can also perform KS test. And KS test says the distribution is not normal. But KS test is non-parametric test, is not that powerful as compared to Zarek-Vera test. So given a choice, we always go for Zarek-Vera test because it's more powerful test for the distribution. If I take one more example, I report. Friends, you can do with me, nothing complicated. Okay, let me take this problem. I think I already have the data. So mod 1 is equal to LM PP tilde then page plus then if you want to see the result, you can see the result. Summary. That's the summary result which we get. Then I save residuals. So let me call it resi equals to residuals. And with 2 so let me first make histogram with the normal curve. So then we can make so it shows curtices is very high, distribution may not be a normal distribution, so many things out of line. So it indicates that the distribution may not be normal distribution. Then Zerach-Bera test. Distribution is normal, KS test. Distribution is not normal. So I don't know why Zerach-Bera. There is also a test which is called SK test. Skewness curtices test. I have to check the library in which this is available. I have to check. Anyway, SK test can be done if you wish, you can see it. Somewhere it will be there. I don't remember the library which we have. Anyway, so if you find that your distribution is not normal, what to do? So testing you can do graphically. By plotting normal curve with histogram and you can use UB test, Zerach-Bera test, and you can use KS test for testing normality. And if you find there is no normality of the error term, what we have to do, then Okay, Rachna, I do that. So once we find that the distribution is not normal, then if your data size is very large because of central limit theorem, you can safely assume that your error term will follow a normal probability distribution. But the condition is sample size should be quite large. It will not be of any concern if we are interested only in estimates and we don't want to do any kind of hypothesizing. The sample size is small, then outliers many times create problem for the normality. If you remove those outliers, then you can ensure that the distribution is a normal distribution. Or you can do some kind of transformation for making the distribution a normal distribution. It may be log transformation, 1 upon x, whatever it is. So if you do some kind of transformation, it's quite possible that your distribution of the error term becomes a normal distribution. Variance of the error term is not constant, then we have a problem which is called problem of heteroscedasticity. The assumption of homoscedasticity is violated and we face heteroscedasticity. Any one of you tell me what are the consequences if your variances are not constant? Will your estimates blue? The answer is no. If variances are not constant, then our estimates will not be efficient estimates and hence no longer blue estimates. They are still linear, unbiased, and consistent, but not efficient. Hence, they are not blue estimators. And if you don't have the blue estimates, then standard errors will become biased and unreliable, and your hypothesizing and confidence intervals will become inefficient or may give you wrong results. Okay. Estimates are still linear, still unbiased, but not efficient, hence they are not blue. How do we deduct it? We can deduct it by taking a scatter plot of residuals against the explanatory variables. Say, for example, like if I make a remember which, okay, BP. So I can make pair of residual and age, weight, lower dot panel is sorry, it's not pair list, it's pairs. Check my condition pairs. Anyway, let me make a plot. Resident and age. Residuals and water. Why this is different? So if you see here, I can plot it for other variables as well. So if you see there is no pattern in it that indicate that distribution may not be having problem of heteroscedasticity. Then we can apply Xeric Vera test C1. And KS dot test Let's see. P-values are coming to be very alternatively very low. So I don't know what's the problem here. KS test is indicating distribution is not normal. Jerek mirror test is suggesting, I really don't know what's happening here. And how to take care of such violation? Again, if you find, heteroscedasticity, one way is obtain the robust estimates of the standard error. So this robust estimates will correct the problem with the standard errors and gives you the appropriate result. Or you can use GLS or weighted average WLS. And third is you can deflate your variables to come out with your problem of heteroscedasticity. So let me see how do we get this. So we have a BP test, the library LM test. So BP test we take the complete model and p-value is 0.3135. Therefore, the model is not suffering from this. If we take this module, that's the predicted value, and then we can have the histogram. Okay. Then BP test, this one. And for getting the standard error, we have to install a package which is called your sandwich package. So you have to install it. Then this is the output, and this says that we should get variance, covariance, heteroscedasticity consistent estimates. So here we get the intercept, which are standard errors, which are adjusted for robustness. So, friend, still we are on the way, and I'm getting requests for the break. So we will go for the break, but before that break, if any one of you have any question, any doubt, let me know.
Thank you very much, sir. So, third session is now complete. Sir, kindly request you to take tea and rest so that you would be again, you would be taking the again.
So what time will we be back?
Sir, 15 minutes, not more than, sir, because it is now 5. So we can meet 5:20, sharp 5:20. 5:15, fine, sir. 5:15. So participants, all of you are requested kindly keep remain with this session and till the end, and the session will again resume at 5:15. So thank you very much to all of you.
Thank you, Nishi sir. Thank you. Thank you, Gupta sir.
ये ऊपर आना कौन है कौन है कौन है कॉलेज में कौन है कोई So can we start? So, welcome sir once again in the fourth session, and all the participants are also welcome. Sir, please take charge and proceed the session. Thank you very much.
What time we are going to close?
Sir, it is the one session. The session is timing is 1 hour 30 minutes. So we can close it approximate 6:30.
Okay. भैया तुम पार्टिसिपेंट की जान ले लोगे चलो anyway.
Up to sir, up to you, sir. Actually.
No. I have no problem. So, friends, having discussed that heteroscedasticity issue, and we can calculate the robust error by making use of for calculating robust error, we have to use a package which is called sandwich. And then we have coefficient test, regression test, variance covariance matrix, which is heteroscedastic, and that's how we get this. If you want output of the coefficient, these are the results of robust errors. Okay. Now, let's see what happens when error terms are correlated with each other. Then we say we have autocorrelation problem or serial correlation problem. When the covariance between the error term of the jth period and error term of the ith period is not equal to 0, then we have autocorrelation problem. And when we have autocorrelation problem, then our estimates will not be efficient. Hence, they will not be blue estimates. And if they're not blue estimates, then we find problem with hypothesis testing and confidence intervals. They are still unbiased and linear and consistent, but they're not efficient. Autocorrelation problem is more serious problem in case of time series data than the cross-sectional data. So if you are working with the cross-sectional data, then forget about autocorrelation problem. Autocorrelation problem can be identified with the time series data. And in fact, many software like Stata does not allow you to test autocorrelation when your data is not a time series data. And you can make the scatter plot of the residuals, seeing the relation between them. And the most widely used test statistic is Durbin-Watson statistics. It's checked for autocorrelation lag 1, okay? And another method which is used is Bruch-Godfrey serial correlation LM test. But as I said, it's a problem in time series data, and since we are not discussing time series data, so I will not be able to deduct, will not be talking about autocorrelation problem. What if my regressors are correlated? If your regressors are correlated, then you will have a problem of what is called multicollinearity. It implies that the covariance between xi and xj should be 0. If it is not 0, then you have multicollinearity problem. If explanatory variables in regression models are having any relation, then there exists non-zero covariance among them, and it creates a problem which is called multicollinearity problem. And in the morning, many of you are talking about multicollinearity problem. Can any one of you tell me if model is suffering from multicollinearity, what happens? What happens to your estimates?
There are higher correlation among the variable itself.
So if variables are having high correlation among them, so what?
So statements are similar.
Huh?
The statements basically what it means.
They are similar. You mean to say that if x1, x2 are highly correlated,
measuring the same thing.
So they are measuring the same thing. What does it mean?
Means like the statement 1 and statement 2 actually represent the similar thing.
Similar thing. So why should we carry 1? Why should we carry 2 if they are expressing the same thing? We should drop one of them.
True.
To get a compact and parsimonious model. Brief model. If x1, x2 are representing the same thing, that's why they have high degree of correlation among them. Why should I use them? Let me use one of them. I will not lose anything. Rather, I will drop one of the variable. I'm able to increase my degrees of freedom. That's good. Yes, Dr. Nishi. Anything else?
Nothing, sir. Thank you.
Any other problem?
So sometimes it happens like the two statements basically are are seems to be similar, but actually they are different in nature. So the respondent basically considered both the statements similar, and they give their response in similar way, in similar line, because they are considering that both these statements are similar. So in this situation, basically again the multicollinearity can be, it means a correlation between two statements may be a high.
Right. So why they, that means they are thinking both are same.
True.
So if they are thinking both are same, then their responses are like that. So why should I use both of them? I should use one of them.
Correct.
Okay. If the intercorrelations among explanatory variable is perfect, that means if the correlation between x1 and x2 is 1 or minus 1, you may not be able to solve the problem and get the solution. The standard errors becomes infinitely large and you are not able to determine the coefficients value. Ordinarily, least square estimators will still be unbiased. But what is the problem? They become highly unstable. So little change here and there will change altogether the values of my parameters. They become unstable and unpredictable. When multicolority is present, that the estimated coefficients are unstable in the degree of statistical significance, magnitude, and so on. R becomes very high, but coefficients are not coming to be significant. That's typical, diagnosis of multicolority problem. Very high R is square, but coefficients are not coming to be significant. OLS estimators and their standard errors can be sensitive to small changes in data. The tool which we use to identify existence of serious multicolority problem is VIF, which is called variance inflation factor. And people suggest a thumb rule. They say that if it is greater than 10, then it's a serious problem. We should take care of it. Otherwise, what should we do? If it is 1, 2, 3, you can ignore it and this issue will not be a serious issue. So if your model is suffering from multicolority, the solution is ignore. Drop variables which are causing correlation. Transforming the variables and identify some underlying factors. But how do we estimate VIF? I show you here. The package which we use for VIF is package car. So VIF of VIF So I have to first run the library car, then okay. Just a minute. नरेंद्र अभी थोड़ी देर में कॉल करता हूँ मैं Let check mode 2. So age and weight, both are having VIF less than 10. That means multicolority is not a serious problem here. That you can check. Let me see if I get somewhere. Okay, so I have a file. So let me import the file, import from Excel. Plus so I call it data M for multicollinearity. We have y, x1 and x2 in it. So model 3 equal to LM. Data underscore M dollar Y data plus data M. That's my summary. And do you observe here something interesting? R square is approximately 45%, but none of the coefficients are coming to be significant. That's a typical case of a multicollinearity problem. Coefficients are not significant, but R square is very high comparatively speaking. Then you have to simply write VIF mod 3. See here. Very large problem. What should we do? Drop one of them because they're highly correlated with each other. And if they're highly correlated with each other, then why should I? They're giving the same information. So why should I have both instead of one? So if you drop one, then multicollinearity problem will not be there. Okay. Regressors are not correlated with error term. That means the covariance between the error term and X is not equal to 0 if this assumption is violated. And this problem is called the problem of endogeneity. And we have no statistical proof for endogeneity problem. But one thing is clear, if X is correlated with error term, then model is suffering from endogeneity problem. And if it is suffering from endogeneity problem, then your estimates will not be blue estimates. If you ask me, there are two serious problems. And most important serious problem is problem of heteroscedasticity. This is one of the serious problem which we have. We have multicollinearity, we have endogeneity problem, and in case of time series, we have autocorrelation problem. How do we check them? How do we test them? That we have seen. If any one of you have any question, most welcome. Any doubt about violation of assumptions? And please remember, if assumptions are violated, there is a big question mark on your result. Nobody will accept it.
Sir,
Yes, Rachna.
sir, can you please again explain VIF, violation inflation factor, variance inflation factor?
So what do you want to know about it? It's a measure that
Sir,
shows
means how can I interpret right? If
they
there
are
is
highly correlated. I show you what does it mean. We get 75.263. If I run a regression model,
okay, sir.
Say EIF result LM this is actually the covariance between the value which we get here is 27.22365. That's equal to 1 minus the correlation between them, and we have to calculate the correlation between them, R square. R square here is 0.9. So if I calculate 1 over 1 minus R square, that's how we get this result. If you see 75.1879, there may be minor differences, but it's by and large same. It's the reciprocal of 1 minus R square between two variables if you regress them. That's how we calculate this. Okay.
Now I understand.
I think it is the regression without intercept. Minus 1. R square is this one. No, it's with intercept. Yes. It's with intercept. It's with intercept. I've taken up to 4 decimal, but if I take larger decimal value, then I think I will get the same values. Okay. Anybody else? Rachana ji, thank you. बहुत स्टेमिना है तुम्हारे में.
No, sir, I am thankful to you, sir.
Keep it up.
To clarify my doubts, sir.
So if there is no question, then let's move to and last topic. That will be by logistic regression. So friends, good evening to all of you. Let's enter into the last session. That's on logistic regression. Says right in your heart that every day is the best day. So friends, welcome to the session on logistic regression. And we have to learn, and we have to learn with understanding. But before we proceed, let me put you a question. What is the most important thing you need in research? Anyone? If you start doing research, what is the most important thing that should be there as an input? Anyone? सब लोग थक गए लगता है. All of you are tired.
Yes, sir.
Nishay, who is from outside India?
Sir, there are 2 3 participants. Mr. Yu He Wei is one of the participants.
Are they still there?
So let me check. Yes, yes, sir. Yu Wei Ye. So he has been from Canada.
Okay.
So there is one more participant basically from Nepal.
Okay.
That
Right.
is the one.
Okay. Great. So whenever you start doing research, what is the most important thing you need for research? You need idea, you need data, you need software, you need tools. What is the most important input for your research? Your idea, your data, your software, your tools.
Idea.
Huh?
Idea.
Yes, Pankaj.
I think idea is the most important thing, sir.
When it will come, nobody knows.
Yes, that's the question.
And when it will get formalized again, nobody knows. People say that, this is the hot topic, we have to do something on it. So for example, cryptocurrency, and they want to do something on cryptocurrency, but they don't have any idea what to do about the cryptocurrency.
Data.
So the idea is very, very important. If you don't have ideas, you cannot do anything. It is your ideas which motivate you to work on your research problems and research projects. So the most important thing is idea. Idea comes from where? From where we get the ideas. Idea gives research issues, research problems for which we are seeking answers. Yes, are the gaps. Research issues, research gaps, research problems, whatever you call them. These are the things for which you are trying to find out the solution. Idea is one of the most important triggers and motivators that will always be with you throughout the journey of the research. I mean, never stop thinking. The day you stop thinking, they say that the day you stop winning. So always be in a journey, always in a state where you are creating newer and newer ideas for which you would like to do some work. And always be curious. If you are curious, then you will learn so many things. If you are not, then you will not. How many of you are curious to know what we are going to study in this topic on logistic regression? When we discuss some topic in econometrics, we have a motivation for the same. The only thing we must appreciate is what is that we want to study in a topic. Nishay, where is that madam, Itilekha?
Yes, sir. Yes.
Itilekha.
Vilekha.
Neha, where are they?
Sir,
in morning, they were asking so many questions about logistics, so I said just wait.
sir, I was not in morning actually. Pranchul was actually taking care. Maybe she had been in the morning session, but Vilekha. No, right now she is not there.
There. Anyway, why should I study logistic regression? That's a simple question to all of you. Why should you study logistic? And explain to, yes, Rachna.
So in the case of qualitative categorical data, when we have to find out the relationship in the model between the categorical data, then we have to use the logistic regression.
Rachna, it's off to you. Tum lagi hui ho. To study dichotomous variables, that what Nidhi is saying. Nidhi, which kind of dichotomous variables are you talking about? Dependent or independent?
Sir?
Dependent or independent?
Sir, that is basically a independent variable. When dependent variable is categorical, in that case, we have to use the logistic regression model.
If we are having independent categorical variables, tea, coffee, yes, no, male, female.
Yes, binary logistic regression.
Right.
Both
So,
are
if your independent variables are binary in nature, qualitative in nature, then use dummy and use multiple regression. No issue. But problem is when your dependent variable becomes binary. Nidhi, we would like to know that if a customer comes to a restaurant, what the probability he will order for tea and what is the probability that person will order for coffee? How do we know that? Suppose you come to know that a person is investing in equity shares. Now, who is that person? Male or female? How do I know? So if you are curious to find out answers to these questions, look at this video clip, penalty shootout. Guess, will this player score penalty? Is it possible for us to predict whether a player will convert a penalty shootout into a goal? What kind of personality that person should have? What should be the success rate of that particular person in the past? How do we know it? And there is two possibilities. He will score a goal or he will not score a goal. And 75 football players were selected random and questionnaire was administered and their anxiety level, their success rate were recorded and effort was made to find out whether they are going to convert a shootout into penalty or not. So we have red ones are missed out, green ones are scored. Percentage of the previous penalty records, questionnaire data to measure the degree of worry, result of the penalty. And then we see how we can model it. Have you ever wondered that what factors improve the chances of making a merger successful? Nidhi, when you said probability formula, what exactly you mean by that probability formula? Ravi, where are you? So active.
Hello. Yes, sir. I'm active.
Do you know how Gmail decides which mail should be put in spam, which mail should not be put in spam?
What you mean, sir? How Gmail decides which mail should be labeled as a spam and which should not be labeled as a spam? Yes, sir. But actually, they have to be in each and every if we are to be any individual persons or any company or any promoter company, they have to be sent. They goes to be directly to the spam. If they are providing any offer, any other things like to be, then it goes to be directly to be in a spam. If individual persons in any institutions or any other companies to be delivered, it comes to be in the inbox or all mail.
Ravi, where you work?
Sir, actually, I am working right now in a Kotak Mahindra Bank.
Okay.
Before that, I am ICICI Bank. In the last 4 years, I have to be.
Okay. Okay. So, Ravi, if you are having official email, that will be institutional email. So,
Yes, sir, pardon?
That will be institutional mail, right?
Yeah.
So you will be having Kotak Mahindra .ac something like that.
Yeah, .com like so. And .co in.
whatever.
Yes.
So it's institutional mail ID, right? So if you
Yeah.
send me a personal email, do you think spam Gmail will put it in spam because it's coming from the institutions?
No, sir, this is not put in the spam. If in the data or in structure in that written in quotation like to be, that's supposed to be in a spam. You know, if a materialistic is fruitful or like a educational or a it's to be a PDF file, to be zip file. In starting, they have to be created for a subject. They are filtered through the subject. Then after that, they are delivered to the in those in a particular Gmail is to be
Many times
provided to be in a spam or
many times
yes,
there
sir.
are errors also. Some important
Pardon,
word.
sir?
Many times there are errors also. Important
No,
word.
actually, error. Yeah. There is yes, errors is to be all in differences, but they have to be Google is provided their services to abandonment in each and every day. And after if you are going through the after night after early morning, 12 to 2, there have to be some corrections to be edited in their workers to be working that almost to editing.
Ravi, can you imagine what kind of algorithm they are using?
So actually, algorithm, I don't know what I found that they have to be using only a coding through basis is that
That's true, but
each and every each
there will be
every
algorithm working at the back of it. That algorithm may be supported by logistic regression.
okay logistic
Suppose
logistic regression.
or logic regression, whatever you call it. Suppose a person comes to your bank to borrow money. How do you will decide whether you should grant credit or should not grant credit? Can you make a model?
Pardon?
Credit model
If
where you can get the probability of extending credit to a person or not extending to a person. How do you know?
we
How do you know that this person is going to make a default?
make a default so through the actually in if a customer is making a default, they have to be certain limits. If we have already provided some kind of loan, then in that loan they have customer is bounces their EMIs in continuity way, like to be in the sixth, like in a six, 1, 2, 3, 4, like 6 in a variable basis to 6 EMI. Then we have to be approached to customer for further discussion. Why, what the mishappening happened in that customer? Why he has not fulfilled or he has not paid to EMI to customers each and every
That
through
is
the personal discussion.
That is afterwards when the default is being identified. But before you grant a loan, can you estimate the probability of default from a person?
Sir, actually no.
एक्सपीरियंस बैंकर कहते हैं हम शक्ल देख के बता देते हैं कि कौन डिफॉल्ट करेगा.
नहीं सर इतना तो है बट एक्चुअली में हम कस्टमर को जब भी लोन देते हैं बिफोर दैट मैं कस्टमर से इंटरेक्ट करता हूँ उसे फिजिकली मतलब उसके घर पे जाके विजिट करता हूँ फिजिकली देखता हूँ सारी चीजें उसका बैकग्राउंड चेक करता हूँ नियर अबाउट सर्चिंग करता हूँ देन मैं देता हूँ इन मेरे जो 4.5 के करियर में मैंने
all that information must be put in the MIS of your bank, right?
Yes sir.
Then MIS will tell you finally what is to be done.
Yeah. Finally, we have to be given or not to be that. If customer is capable, they have to be like these kinds of assets. And if customer making a default, then we are making a charge, and they have to be like in comparison to this much amount, they have to be more than that amount to be assets or liabilities, whatever to be.
Ravi, these are the
And we have to
examples. These are the examples where logistic regression is used widely. If a customer is hitting a e-commerce site, what the probability that he will make a sale? So there you will find logistic regressions are used very, very widely. So friends,
Okay,
what
sir.
if my dependent variable is a binary variable? For that, we have to work with the logit, probit, or probability model. So we shall talk about a situation where my dependent variable is a dummy variable. And to begin with, let's work with linear probability model, and then we move to logit and probit model. Why do we need a separate discussion on a model with binary dependent variable? Why can't we use simple OLS? Anyone? Nidhi, you are very active. Tell me, why I can't use OLS? Why I need something different? OLS, what OLS does? Minimize y minus estimate of the y square summation with respect to alpha and beta. When binary, y is binary, then I cannot use the calculus to get the minimum values, which OLS requires. And therefore, you cannot use OLS. OLS has other problems as well. So we need something different. Let's consider a problem. There are 33 solvent companies, 33 bankrupt companies, and we have made a model. 0 means company is bankrupt. 1 means the company is a solvent company. And these are the financial ratios which are used for modeling purposes. And suppose I get a value 0.75, what does it mean? I take, say, tea or coffee, right? Whether a customer will ask for tea or coffee. So my dependent variable is binary, representing 1 for tea, 0 for coffee. Maybe function of price of tea, price of coffee, okay, and error term. Suppose I take only 2. And suppose I get a value here 0.75. What does it mean? How do we interpret this? Nidhi, how do we interpret this value? OLS negatively impact type 1 error. Nidhi, how this type 1, type 2 error is coming into mind? Type 1 error, type 2 error is related to hypothesis testing. Anybody guess what this means, 0.75? If you take a general model like this, the expected value of y given x is this one. That's equal to 0.75. What is this? Expected value of y given xi. So y can be 0 or 1 given x. with probability P and 1 minus P. What is the expected value of Y? So expected value of Y given X is by P. If I increase X by 1 unit, Y will increase by 0.75 units. Nidhi, 0.75 is not the value of the coefficient, it's the value of the estimated Y. So this interpretation will not work. The value which we get is called the probability value. Probability that your Y will take a value 1. You call it expected value of Y given X, or you call probability, one and the same thing. So you can see 1 into Pi, 0 into this. So the estimated value which we get is probability that Y will take a value 1. And since it's a linear function, so we call it linear probability model. And that's the probability of Y taking value 1. This is taking 0. If we use this kind of a model, can you imagine the problem with this model? If we have a model like Y is equal to alpha plus beta X plus error term, and Y represents probability that Y takes a value 1. Can you imagine what's the problem with this model? We don't use it. In fact, we never use it. It's only for theoretical discussion purposes. It's a linear model. It's a line. No bound on it. And if there is no bound on it, that means it may take a value less than 0 or more than 1. But probability value should always be between 0 and 1. And if it is taking value negative and positive more than 1, then we find difficulty in its interpretation. Y is dichotomous, binomial. Therefore, error term follows not the normal distribution, but binomial distribution. Rohit, what is the variance of binomial distribution? What is the variance of the binomial distribution? Anybody? Do you remember this?
Yes, sir.
What is the meaning of it? As n increases to infinity, your variance becomes infinity. That means model is suffering from heteroscedasticity. Risk is not constant, variance is not constant. Risk, variance, both are used interchangeably. That's again a problem. It should follow normal probability distribution. It is not because it's binomial, so follow the binomial probability distribution. Its variance should be constant. It's not because its variance is NPQ, which is the function of n. Nearer term are not homoscedastic, but they have a problem of heteroscedastic. And the value lies between 0 and 1. That's what we wish. So we need a nonlinear function. This is my x. This is my probability. I need a function which will always give me a value between 0 and 1. Always, whatever value you take. You take plus infinity, 1, minus infinity, 0. Can you imagine what kind of function we need? It cannot be linear function, I tell you. Because the problem with the linear function is that either it increases or decreases without any bound. It has to be nonlinear function. And a nonlinear function should be something like this. That means we are looking for S-shape function. And people have suggested two S-shaped functions. So please appreciate we cannot use OLS for binary dependent variable model because the problems which we have already discussed. Logistic function and standard normal probability distribution. This is my logistic function. If x is minus infinity, what happened to the value of y? Anyone quick? And if x tends to plus infinity, what happened to the value of y? Quick, Rohit. Rohit. Y become extremely small. Nidhi, for x tending to minus infinity or plus infinity? Plus. No, Nidhi, it's not like that. If it is minus infinity, so what we get 1 over 1 plus e to the power minus infinity, 1 plus e to the power plus infinity, which is equal to 0. And if it is plus, then this becomes 0. This becomes equal to 1. So you take any value between minus infinity to plus infinity, the result of this function will always be between 0 and 1. And that's what we wish. Okay, and if you take the cumulative standard normal probability distribution, we always know that probability distribution always lie between 0 and 1. So if I make use of normal probability distribution, I'm working with probit logistic logic model. We shall work with this. We shall not be working with this. That's how the function looks like. S shape. So pi is equal to 1 upon 1 plus e to the power minus z, and z is equal to
आ रहे हैं आप मतलब आप आएंगे ना तो बिना
so my pi is equal to 1 over 1 plus e to the power minus z. So 1 plus e to the power minus z is equal to 1 over pi. And to make it positive, what we get is Nidhi, what is it? P over 1 minus P. Nidhi, what is P over 1 minus P? This is called odd ratio. And if you take a log of it, you get Z. So my Z is log of Pi over 1 minus Pi, that is log of odd ratio. That's my Z. So if you know Z, you can calculate the probability, you can calculate the odd ratio and things like that. So log of odd ratio is my Z. And if you take exponent of it, odd ratio is what? Exponent of Z. The method which we use, we can't use OLS, so we are going to use the maximum likelihood method for estimating logit model. Which one we should use, logit or probit? Normally we go for logit because for probit you need the normal probability distribution tables and all that, mathematically complicated. So we prefer to use logit, and by and large both give the same result. And normally we define a threshold which is 0.5. Anything less than 0.5 means it belongs to 0. Anything above it, that means it belongs to. It's a threshold adopted by most of the software, but if you want to change, you can change your own threshold. And how do we know which model is a good model? Can we use R square or adjusted R square here? The answer is no, because we are using maximum likelihood method. So what we need? We need something to check the goodness of fate. R square, adjusted R squares are not available, but we mimic something like R square, and for that we get what is called pseudo R square. They're not actually R square, but they mimic R square. And of course, higher the value of the pseudo R square, better is the fit. And widely used one is McFadden's R square. Then we have Cox-Snell pseudo R square, and we have Nagelkar measure of pseudo R square. Different R square measures are available, but widely used one is McFadden. Any question before we go ahead? So now we are clear. We have to work with logistic regression when my dependent variable is binary. I cannot use OLS. I have to use something else. That something else is maximum likelihood method. Okay. Third thing which you have to remember is R square, adjusted R square, we cannot calculate because we are using maximum likelihood method. So we use pseudo R square measure to get an idea about goodness of it. Any question before we go ahead? Neha, you are back. Any question?
Sir, you are going so fast, sir. We are skipping so many things. In the last slide, sir.
Rachna, there is nothing complicated in it, I tell you.
Yes, sir.
You have a dependent variable. Independent variables. They may be binary, they may not be binary, doesn't matter. But my dependent variable is binary. The value of the binary variable which we get that represents probability that y takes value. I cannot use OLS, so I have to go for something called maximum likelihood method. And if I go for maximum likelihood method, I cannot get R square, adjusted R square. So I have to use something similar to that pseudo R square. And we use logistic because logistic gives me a shape function. That means its value will always be lying between 0 and 1. Rachna, where is the problem in it? We are not going to do anything manually. It's all through software. Software requires input. We know what kind of input we have to give. We also know how to interpret the output. So where is the problem? Anybody else? No? Okay. Let's see what next. Let's apply our learning using computers and I think I take you directly to so let me read the heart attack data. So I go to File, Import, Excel. logit heart attack data. We have the second heart attack, treatment of anger, treatment of anxiety. So we are trying to find out what are the chances that, there will be second heart attack. So we just read this data. Okay, so if you view, you can see the structure. Structure of the data is like this. That the structure of the data which we have. So the command for the logistic regression is GLM, General Linear Model, and you have to write same dependent followed by independent, and the family which we have is binomial. GLM, dependent followed by independent, then family of the function which you're using is binomial. That's the command which we use. So we run it. You can see the coefficients. You can get the summary. If you want, you can get the coefficients. And we are predicting the membership by using the threshold value. If it is 0.5, it's 1. Otherwise, it's 0. So we're trying to predict the belongingness of the data. Then install this package. Then calculate MPR2 logit model. It gives you McFadden, and you can compare it with other model McFadden R square and decide whether this model is a good model. And exponent of the coefficient of the logit model gives you odd ratio. So these are the odd ratios of my variables. Okay, I show you how can we do it by taking altogether a new model. File, import, Excel. Brand data. I just take brand. So market share, profit margin, whether company is a big company or small company, and how is the impact of these three variables on the brand. So my equation is brand equal to your alpha plus beta 1 profit margin plus beta 2 market share that's the model which you are working with. So I just then I just copy the data from here. So this is brand brand, then followed by independent variables. Followed by independent variables, which are your brand, market share, plus brand profit margin. plus size, comma, family binomial, that the trend, okay, trends market share plus brand. Just writing the command plus plus
सर
इसमें क्या
ये फाल्स पे FELSC लिखा हुआ है आपने
क्या
सर ये नीचे जो कमांड दी आपने अभी इफ फंक्शन एल्स तो ये समझ में नहीं आया ये यहाँ कंडीशन क्यों लगाई है
फैमिली बाइनोमियल
सर ये जो लास्ट प्रेडिक्ट रिग्रेशन कोफिशिएंट से नीचे सर
ये वाला प्रेडिक्ट का
जी सर
ये मैं भी आता हूँ इसके ऊपर पहले ये देख लेता हूँ ब्रांड ये आ गया मेरा चेक प्लस प्लस I don't know why it's showing me error. family is equal to this. Size is this. I don't know what's happening here. GLM, this. I'm using the same syntax, but why this problem is coming? Let me rewrite again. What I do is I attach think let me rewrite again. I don't know why it was not giving earlier. Anyway, so we got the result. This is the result. This is the summary. This is the coefficients, if you wish. Right, this is the predicted value which we get. And Rachna, this 0.7, 0.5 is my threshold point. So what I'm saying is, if my predicted value is more than 0.5, assign it 1. Otherwise,
sir.
assign it to 0.
Okay, sir.
Then we drag to I have to check it. And this gives me the McFadden R square higher. This is giving me odd ratios. So these are the inputs out. sorry, the result which you can get by using logistic regression. Logic model. This is my brand. That's the table which we get. I don't know why I'm not able to get the table. Table, I should get logic model brand type response. So anyway, but that's the way you can calculate this. And similar thing you can do with other problems. What should be the logic model? That logic model you can make. I'm not going to use this data command. We should go for logic model. That's what we said in the beginning. And these are the assumptions which are making for our logistic regression, dependent variable binary, and sorry. Observations, the data should be independent of each other, should not be any collinearity. Non-linearity should be there in the dependent variable. Sample size should be preferably large. Logistic relation does not require linear relationship because the relationship is non-linear. Error terms need not to be normally distributed. Assumption of homoscedasticity is not required. And we can see the relationship. Sign of the coefficient shows the direction of the relationship. Positive, negative, that you can. Beta represents the marginal rate of change in the, sorry. Beta represents the marginal rate of change in the log of alteration. Effect of a unit of X on the predicted value of logit of the log of alteration. And if you take the exponent of the coefficient, we get alterations. And since it's a nonlinear function, so its probability changes with every change in the value, and that's the formula which we use. So change in the probability with respect to a given xi will be equal to beta of that xi probability 1 minus probability. This will give you the marginal rate of change in the probability with respect to x. I'm sorry, I have to be little fast, but anyway, you get broadly an idea about logit. If you have any questions, then we wind up the sessions. These organizers ask me to pack up so many things in a day, and that too with R. So problem with the R is you have to be comfortable with the R. If you're not comfortable with the R, then you'll be in trouble. Yes, Nishay.
Sir, there is a query, sir. Actually, participants are asking about the PPT.
No problem.
Sir, kindly share your mail ID, please, because it is very difficult to move up all the things.
Are you talking to me?
Right.
Hello. Are you talking to sir or to me?
Me. Talking to me. That's my email address.
So, sir, can we just conclude the session, sir? Can
Yes,
I?
yes,
So
yes.
fine. So, thank you very much, sir, for conducting a wonderful session on the regression using the R and the definitely this will be helping us in learning its various aspects. So, thanks once again, sir, to you. Thanks to each and every participant who became the witness for the session, and ensure that they all of us basically must have got it something very new aspect. We have learned the very new aspect related to the regression, logic, probit, etc. So certainly it will be helpful in future too also. So now behalf of the Prestige Institute of Management Gwalior and from my own behalf, we would like to just show the gratitude. So, sir, just a minute. I'm just going to share the gratitude letter to you, sir.
Thank you, Dr. Nisha. Thanks. Thanks, everyone.
Just a minute, sir.
Okay.
Sir, can you stop sharing, sir, please? Can you stop sharing, sir, please? Yes, sir. Thank you very much, sir. This is the gratitude letter, sir, from our side to you. Thank you very much, sir.
Thank you, Dr. Nisha. Thank you.
Thank you, sir. Thank you.
Thank you.
Good day, everyone. Kindly fill the feedback form and submit it, please, sir. Thank you.
Thanks, everyone. And I understand full day, heavy dose. The regression and at the top of it, the advanced topics of the regression and with R, that really make the things very, very complicated. So I hope whatever we could do in this limited time, we are able to do it. Thanks, everyone. And please remember, it's a beginning to all of us, and take it further. The more you practice, the more you learn, the more you will become expert in it. Thank you. Thanks.
Thank you, Wordsworth, sir. Thank you.
Thank you, sir.
Thank you, Rachna. And I have given you my email, simpleguptacp@gmail.com.
Sir, I definitely write queries regarding this.
Yes, yes.
Question.
Dr. Risha, should I leave?
Yes, sir, please, sir.
Okay.
I'm just going to close it.